Welcome to this course. A primary concern of just about anyone who uses a computer is the security of their system and their data. People want to be assured that they are safe from external threats, free of vulnerabilities, and able to recover from data loss. A big part of being an IT professional in a support role is helping people gain this peace of mind, and fortunately, you are in the right place to learn the core knowledge needed to make that happen. In this course, you'll become familiar with some of the most important elements of IT security and data management, namely secure software setup, advanced hardware configurations, and effective strategies for data backup and recovery. This course is designed and built by subject matter and industry experts in the field. Every lesson has been created to equip you with theoretical and practical knowledge and real-life problem-solving skills to be successful in an entry-level job. Now let's go over some of the topics that you can expect to explore. You'll begin by focusing on software security. This starts with becoming aware of common threats to a system, such as malware, malicious users trying to gain illicit access, and vulnerabilities that can appear over time. You'll then discover the primary tools and practices for protection against these dangers, including firewalls, user authentication methods, and software updates. Next, you will move on to the hardware side of things and increase your understanding of how configurations impact security. You'll learn about the basic input-output system or BIOS, which interacts with many hardware components and plays a large role in the computer boot-up process. Building upon this fundamental knowledge, you will discover how to improve hardware security through such means as storage encryption and managing physical access to devices. The following part of the course covers data backup and recovery, which is essential to averting disaster should you lose your data. You'll dig into several backup methods and strategies, and along the way, you'll also increase your familiarity with data processing and storage in general. To wrap things up, you'll end the course by taking on a final project and assessment. The project requires you to synthesize your knowledge to devise a data strategy for a business that meets security, processing, storage, and backup needs. The course is part of your preparation for the MS900 Microsoft 365 Fundamentals exam. Taking the MS900 exam will set you up for a career as an IT professional. The great thing is, you don't need a background in IT-related fields to take this course. It is for anyone with an affinity for technology and an interest in IT support. In summary, this course provides you with a complete introduction to hardware, software, and data backup and prepares you for the MS900 exam. And now that you've reached the end of this course introduction, it's time to start your learning journey. Modern digital technology has enabled people to share information more easily than ever before. However, this also heightens the potential of data falling into the wrong hands. For example, attackers may try to gain unauthorized entry into online accounts where they can access sensitive personal or financial information. Fortunately, there are steps you can take to improve protection from such threats. In this video, you'll receive a comprehensive introduction to the basic concepts to help ensure you feel comfortable dealing with security-related issues. After completing this video, you'll be able to identify common vulnerabilities, list types of security threats, and understand the significance of keeping software up to date. In addition to knowing the potential kinds of threats that one needs to defend against, you will learn about the defensive strategies that are employed, such as defense in depth or DID, and the use of encryption, which is an established means of further safeguarding information in the event of a breach. Let's begin by discussing the importance of software security. This plays a critical role in protecting sensitive information and ensuring the integrity and reputation of any business with an online presence. As technology advances, so do businesses' increasing reliance on online solutions. At the same time, the methods employed by malicious actors to exploit vulnerabilities in software have become more sophisticated. This is natural when you consider the increasing payoffs from launching cyber attacks. By comprehending the importance of software security, individuals can proactively mitigate risks and protect against potential threats. Software vulnerabilities encompass weaknesses or flaws that attackers can exploit, ranging from coding errors to design flaws. An example is buffer overflow, which is when the memory is overloaded with information and requests. This happens when the input exceeds the buffer's capacity. Some hackers intentionally try this, as this can create vulnerabilities that enable them to gain entry or insert malicious code. By comprehending various software vulnerabilities, individuals can proactively implement measures to mitigate the risk of exploitation. One method for preventing buffer overflow is to write code that validates user input before copying it to buffers. This could mean setting a maximum length for input data or only allowing certain data types or formats. This stops a would-be hacker from entering too much information into the system, which protects the buffers. Identifying how the breach occurs empowers us to employ appropriate defenses. This video explores various security threats software systems face when executing the business's day-to-day functions. Hacking, phishing, and malicious software are among the most prevalent threats. Hacking involves unauthorized access to systems, while phishing aims to deceive individuals into revealing sensitive information. Malicious software, such as viruses and malware, can cause significant harm to software and compromise data security. One major attack that afflicted thousands of computers worldwide and cost billions of dollars in damage was perpetuated with WannaCry, an insidious malware that prevented legitimate access to the system by the owners until a ransom was paid. Regularly updating software is crucial for maintaining its security. Software developers frequently release updates that address known vulnerabilities and enhance security features. By keeping software up to date, individuals can ensure that their systems are equipped with the latest security patches, reducing the risk of exploitation. Once an exploitation becomes known, security experts will analyze its pattern and alter the code to protect against it. Microsoft released a patch in March 2017 which defended against WannaCry. The fix involved limiting access to some ports. Despite this, many computer systems continue to fall prey to it as users did not install the security update on their system. Defense in depth is a foundational principle in software security, which involves the implementation of multiple layers of security measures. Individuals can establish a robust defense mechanism against potential threats by integrating physical, technical, and administrative controls. For example, multi-factor authentication methods, such as receiving a verification code via email after entering a password to access an application or account, exemplify the intricate nature of DID aimed at preventing unauthorized access. Such strategies are commonly encountered in various technological interactions, underscoring their widespread applicability in safeguarding sensitive information. Preventing unauthorized access is an important measure in digital security, but it's not the only one. Encryption also plays a vital role in protecting data integrity and confidentiality. Encryption ensures that only authorized individuals can access and decipher the information by converting data into an unreadable format. Encryption methods have become very convoluted since their early incarnation. Typically, one can encrypt data by generating a cipher that will alter human-readable code into an unrecognizable collection of text and symbols. This same cipher can then unscramble the text given the encrypted form. Encryption can be applied at various levels for increased security. For instance, encryption at rest means that data stored in company accounts is encrypted so that if a hacker were to gain entry, they would not be able to use the information obtained. Another typical example is encryption in transit, where information is encrypted before being sent over a network. This is a common internet practice, and all data is encrypted before being sent. Encryption is another example of DID, as it provides an additional layer of protection. In this video, you received a comprehensive introduction to the core concepts of software security. By understanding the importance of software security, the nature of software vulnerabilities, types of security threats, and the significance of keeping software up to date, you've equipped yourself with essential skills to safeguard digital environments effectively. You also explored the concept of defense in depth and the role of encryption in protecting data integrity and confidentiality. By doing so, you have gained awareness of some important strategies for mitigating risks from online threats. Upon installing a software application on your computer, you've likely encountered a lengthy document that specifies what you can and can't do with it. But have you ever taken the time to read these conditions before agreeing to them? In this video, you'll become familiar with the End User License Agreement, or EULA, a critical but often overlooked aspect of software installation and use. You'll come to understand why it is a standard part of the software installation process as well as the potential legal and security consequences of ignoring the terms in a EULA. The EULA is a significant software installation and use component. While it may often be agreed to as an afterthought, it is important to understand the nature of the information that it presents. A EULA is a legal contract between the software developer or vendor and the end user, outlining the terms and conditions under which the software can be used. It also offers customer protection, outlining what security and privacy measures are afforded with the use of the software. Before engaging with various software, it is worth pausing at this important feature. One of the primary purposes of the EULA is to define the rights and limitations of the end user. It specifies how the software can be used, whether for personal or commercial purposes, and whether it can be installed on multiple devices or shared with others. The EULA may also outline any restrictions on modifying or reverse engineering the software. This can have consequences if your company embeds the software in an application they aim to commercialize. Knowing the viability of this before beginning work could save wasting future time and effort. Additionally, the EULA often includes information about warranties and liabilities. It may specify any guarantees or disclaimers regarding the performance or functionality of the software. For example, it may state that the software is provided as is without any warranty of fitness for a particular purpose. It may also limit the liability of the software developer or vendor for any damages that may arise from the use of the software. However, it is worth noting that the software creator typically drafts a EULA and as such will have a bias toward the restriction on the use of the software over consumer rights. Ignoring the terms set out in a EULA can have significant consequences, both legally and in terms of security. From a legal standpoint, violating the terms of a EULA can result in legal action by the software developer or vendor. This can lead to financial penalties or even injunctions against the continued use of the software. End users must understand that accepting the EULA is entering into a legally binding agreement. However, for it to become binding, the customer must select the consent button before downloading or installing. While the creator can inform the buyers of the software's agreement, the contract's terms must be considered fair. Overly one-sided agreements or conditions that are deemed unjust will not be enforced by the courts. This includes using excessively obtuse language designed to obscure the intent of the clause. From a security perspective, ignoring the terms of a EULA can expose users to various risks. For example, some software may collect personal information or track user activities, and the EULA may outline how this data will be used and protected. Ignoring these terms could result in a violation of privacy or the misuse of personal information. Another side effect of violating the EULA can be loss of support and updates. This can have security ramifications if the developer does not send the latest security patches and updates, as companies may find themselves vulnerable to known exploits. Furthermore, some software may have hidden costs or unexpected charges associated with its use. The EULA may disclose any additional fees or subscription requirements that users must know. Ignoring these terms could lead to unexpected financial burdens. Despite the typically mundane nature of EULAs, some companies inject humor and creativity into their legal documents. Let's check out some examples of the more famous or infamous twists. The EULA for Zombie Apocalypse Survival Kit, Amazon's Lumberyard 3D gaming software, famously includes a provision allowing users to utilize the software for critical systems like nuclear facilities, but with an intriguing exception. In the event of a zombie apocalypse, users are granted the permission to modify the software freely to create zombie-defying technology. iTunes is strictly off-limits for anyone harboring dreams of turning it into a nuclear launchpad. In a tongue-in-cheek fashion, Apple makes it abundantly clear that if you ever find yourself tempted to transform your music library into a doomsday device, you will be violating the EULA and might just land yourself in some serious trouble. Finally, a UK game store once humorously offered a discounted Eternal Soul on April Fool's Day with an end sole user license agreement stipulating the company's right to claim the purchaser's immortal soul within 5 days. Surprisingly, only 12% of users rejected this clause, highlighting either the value people place on their eternal souls or the typical mistake we all make at some point or another, overlooking the fine print. In this video, you found out how the end-user license agreement is critical to software installation and use. You now know that it defines the rights and limitations of the end user and outlines important information about warranties, liabilities, and usage rights. You also discovered that ignoring the terms set out in a EULA can have legal and security consequences, including privacy violations, software misuse, and unexpected charges or penalties. Users must read and understand EULAs to make informed decisions and ensure better personal and organizational cybersecurity practices. With the amount of data that is constantly moving in and out of your computer or network, how can you keep track of the unwanted content that could potentially get through? You'll be glad to know that one of the first lines of defense is also one of the most effective. In this video, you will be introduced to the role of software firewalls and how they safeguard computers and networks from various threats. You'll discover how they monitor and control incoming and outgoing network traffic and distinguish between them for security purposes. You'll also learn about basic firewall operations, such as blocking or permitting traffic based on predefined security rules, and the concept of rule prioritization, a key feature in managing the order in which the firewall applies these rules. So let's begin by defining what exactly a software firewall is. A software firewall is a security program that monitors and controls incoming and outgoing network traffic. Its primary purpose is to act as a barrier between a computer and potential threats, such as unauthorized access or malicious software. A computing system can have multiple firewalls working together. For instance, as well as having a computer firewall, a network will have a firewall that filters incoming and outgoing traffic. One task of a network firewall is to analyze network packets. These are the individual items sent over a network. A network firewall will apply different rules to these incoming packets that inform whether they are allowed access or stopped at the gates. When the laptop connects to the company server, it will come under the umbrella of the firewall for that network. The computer's own firewall will add further protection against unwanted incursion. Network traffic can be categorized into two types: inbound and outbound. Inbound traffic refers to data coming from external sources and attempting to enter a computer or network. On the other hand, outbound traffic is data originating from within the computer or network and trying to communicate with external destinations. Software firewalls distinguish between these types of traffic to ensure system security. This can make firewalls versatile, as they can protect a company from external intrusion, but also they can be used to ensure that company data is not sent out inappropriately. Unusual traffic may indicate an active breach, where a hacker extracts company data, but it may also identify a worker illicitly extracting information. Next, let's move on to basic firewall operations. Software firewalls implement predefined security rules to block or permit network traffic. When a packet arrives at the firewall, it is inspected against these rules to determine if it adheres to acceptable income messages. If the packet matches a rule that permits it, it can pass through. Conversely, if the packet matches a rule that blocks it, it is discarded. This process is crucial in preventing unauthorized access and protecting sensitive data. Firewalls are often crafted as a result of developing many rules over time. Sometimes these rules can even be conflicting in nature. However, there is an order in which each rule is applied. Rule prioritization is a key aspect of managing a software firewall. When multiple rules apply to a packet, the firewall must determine how to apply them. This is important to distinguish when to take action in the event of conflicting rules. Prioritization will result from the importance the developer places on it when creating the rule. First, the developer will create a rule, such as allowing all outbound traffic from ports 2000 to 3000. The developer will include a level of priority that begins at 0. There is no concrete cessation, and lower numbers are considered first. Popular operating systems like Windows and Mac OS come with built-in software firewalls. These firewalls provide a basic level of protection and can be configured to meet specific security requirements. Windows Firewall, for example, is a software firewall included with Windows operating systems. It allows users to define inbound and outbound rules, customize security settings, and monitor network activity. Similarly, Mac OS includes a built-in firewall that can be enabled and configured to control incoming connections. Both operating systems offer proprietary firewalls supported by Microsoft and Apple, respectively. Mac firewalls tend to be more customizable to specific applications, but overall they exhibit much of the same functionality. By watching this video, you've developed your understanding of software firewalls, their functions, and how their rules are prioritized. They are a vital tool for safeguarding computers and networks from threats. You now know that a computer might enjoy the protection of multiple firewalls at different entry points. There are different types of network traffic, firewall operations, rule orders, and built-in software firewalls found in popular operating systems. Understanding rule prioritization and the nature of firewalls will be crucial for an IT professional who may be tasked with configuring network firewalls or activating an employee's firewall in a company laptop. Controlling access to data and systems is one of the fundamental aspects of keeping modern businesses operational and secure. IT professionals face the challenge of maintaining a secure network, but also allow some flexibility in handling human or system errors. User authentication is central to this issue. This video is about troubleshooting common user authentication problems to maintain secure access control systems while building a user-friendly system that empowers workers to achieve their goals. Let's take a moment to define user authentication. User authentication is the process of establishing that the person accessing a system is indeed that person and not an imposter attempting to gain access using legitimate credentials. It is an essential buttress in the cyber defense arsenal, ensuring that only authorized individuals can access sensitive data and systems. However, authentication issues can arise, such as login failures, password recovery, locked accounts, and multi-factor authentication challenges, to name a few. Let's explore some of these issues, starting with one of the most common ones, login failures. This can occur due to incorrect credentials, expired passwords, or system errors. By identifying the root cause of login failures, IT professionals can quickly resolve the issue and restore user access. Next, let's discuss password recovery. A well-known security measure is to force employees to change their passwords periodically. By systematically altering passwords, a company can reduce the risk of an external identity discovering passwords or nullifying compromised passwords. However, a security measure such as this poses its own challenges. For instance, the company will need a process that enables legitimate password recovery or the ability to unfreeze locked accounts. The password reset process in itself creates a back alley by which a hacker can access the system without the appropriate password. Conversely, manually verifying that every password reset request is legitimate will be time-consuming and costly. Or consider a scenario where an employee gets locked out of her account after entering an incorrect password multiple times. This is another common defensive mechanism to prevent dictionary attacks, where a hacker uses a legitimate access ID with a sequence of guessed passwords. Typically, a hacker uses a program that starts at the beginning of a dictionary and attempts each word with the login ID. To stop this, IT professionals will lock the account after a preset number of incorrect attempts. However, excessive login attempts may also simply result from human error when forgetting a password, especially if a company enforces a password reset policy. Authentication issues can also manifest in multi-factor authentication or MFA processes, especially when users encounter difficulties with secondary authentication methods. So, to troubleshoot MFA issues, you need a deep understanding of the specific authentication process to identify and resolve any obstacles users face. Let's discuss it in a bit more detail. MFA refers to using at least two different ways to confirm that the identity accessing a system is who they claim to be. Typically, there are two different identification methods to verify this. For instance, resetting a password might require that a user provide an old password, or a user might have to verify an email address. Another MFA method is to ask a user to provide a code sent to a registered device. MFA is an example of defense in depth, or DID, as it provides multiple obstacles to illicit entry. To troubleshoot user authentication problems effectively, IT professionals must have a systematic approach. This includes gathering information about the issue, analyzing potential causes, and implementing solutions based on best practices and security protocols. Recall the trade-off discussed with password resetting. To ensure that hackers do not exploit this defense strategy, the IT department must gather different information points on the user. Equally, they must decide if the system will be automated. If not, what will the allowed access hours be? To manage a 24-hour service will require an entire team of administrators working on a schedule. On the other hand, the lack of human monitoring may increase the chances of a hacker misusing the password reset process to break into a system. Finally, access issues can also result from system errors. Events like the loss of server access, database errors, network errors, and even software errors might prevent legitimate access to a system. Adding to the complexity, incorrect error messages such as account logout might mask these system issues. To keep account of these cases, IT professionals should ask, why did the system not receive the correct password or ID? Was there a human or computer error? Are there legitimate reasons or indications of malicious intent? IT professionals can pinpoint the source of the problem by examining system logs, error messages, and user reports and take appropriate action to resolve it. In this video, you learned about the challenges IT administrators face in resolving common authentication problems and ensuring the security and integrity of access control systems. IT professionals can maintain a secure user environment by understanding the root causes of login failures, locked accounts, password recovery issues, and MFA challenges. By following practical troubleshooting strategies and best practices, you can handle authentication issues with confidence and expertise. But there is always a trade-off between security and accessibility. Remember, the simpler it is to reset a password, the less secure your system is. On the other hand, the harder it is, the higher the risk of system lockout and decreased productivity. User authentication plays a pivotal role in the balance of securing a network and maintaining the flexibility to address human or system errors. Controlling access to data and systems is one of the fundamental aspects of keeping modern businesses operational and secure. IT professionals face the challenge of maintaining a secure network, but also allow some flexibility in handling human or system errors. User authentication is central to this issue. This video is about troubleshooting common user authentication problems to maintain secure access control systems while building a user-friendly system that empowers workers to achieve their goals. Let's take a moment to define user authentication. User authentication is the process of establishing that the person accessing a system is indeed that person and not an imposter attempting to gain access using legitimate credentials. It is an essential buttress in the cyber defense arsenal, ensuring that only authorized individuals can access sensitive data and systems. However, authentication issues can arise, such as login failures, password recovery, locked accounts, and multi-factor authentication challenges, to name a few. Let's explore some of these issues, starting with one of the most common ones, login failures. This can occur due to incorrect credentials, expired passwords, or system errors. By identifying the root cause of login failures, IT professionals can quickly resolve the issue and restore user access. Next, let's discuss password recovery. A well-known security measure is to force employees to change their passwords periodically. By systematically altering passwords, a company can reduce the risk of an external identity discovering passwords or nullifying compromised passwords. However, a security measure such as this poses its own challenges. For instance, the company will need a process that enables legitimate password recovery or the ability to unfreeze locked accounts. The password reset process in itself creates a back alley by which a hacker can access the system without the appropriate password. Conversely, manually verifying that every password reset request is legitimate will be time-consuming and costly. Or, consider a scenario where an employee gets locked out of her account after entering an incorrect password multiple times. This is another common defensive mechanism to prevent dictionary attacks, where a hacker uses a legitimate access ID with a sequence of guessed passwords. Typically, a hacker uses a program that starts at the beginning of a dictionary and attempts each word with the login ID. To stop this, IT professionals will lock the account after a preset number of incorrect attempts. However, excessive login attempts may also simply result from human error when forgetting a password, especially if a company enforces a password reset policy. Authentication issues can also manifest in multi-factor authentication or MFA processes, especially when users encounter difficulties with secondary authentication methods. So, to troubleshoot MFA issues, you need a deep understanding of the specific authentication process to identify and resolve any obstacles users face. Let's discuss it in a bit more detail. MFA refers to using at least two different ways to confirm that the identity accessing a system is who they claim to be. Typically, there are two different identification methods to verify this. For instance, resetting a password might require that a user provide an old password, or a user might have to verify an email address. Another MFA method is to ask a user to provide a code sent to a registered device. MFA is an example of defense in depth, or DID, as it provides multiple obstacles to illicit entry. To troubleshoot user authentication problems effectively, IT professionals must have a systematic approach. This includes gathering information about the issue, analyzing potential causes, and implementing solutions based on best practices and security protocols. Recall the trade-off discussed with password resetting. To ensure that hackers do not exploit this defense strategy, the IT department must gather different information points on the user. Equally, they must decide if the system will be automated. If not, what will the allowed access hours be? To manage a 24-hour service will require an entire team of administrators working on a schedule. On the other hand, the lack of human monitoring may increase the chances of a hacker misusing the password reset process to break into a system. Finally, access issues can also result from system errors. Events like the loss of server access, database errors, network errors, and even software errors might prevent legitimate access to a system. Adding to the complexity, incorrect error messages such as account logout might mask these system issues. To keep account of these cases, IT professionals should ask, why did the system not receive the correct password or ID? Was there a human or computer error? Are there legitimate reasons or indications of malicious intent? IT professionals can pinpoint the source of the problem by examining system logs, error messages, and user reports and take appropriate action to resolve it. In this video, you learned about the challenges IT administrators face in resolving common authentication problems and ensuring the security and integrity of access control systems. IT professionals can maintain a secure user environment by understanding the root causes of login failures, locked accounts, password recovery issues, and MFA challenges. By following practical troubleshooting strategies and best practices, you can handle authentication issues with confidence and expertise. But there is always a trade-off between security and accessibility. Remember, the simpler it is to reset a password, the less secure your system is. On the other hand, the harder it is, the higher the risk of system lockout and decreased productivity. User authentication plays a pivotal role in the balance of securing a network and maintaining the flexibility to address human or system errors. Single sign-on, or SSO, is critical in access control and privilege management. It serves as a mechanism that allows users to access multiple applications or services using a single set of credentials. This video will explain the fundamentals of SSO, its benefits, its associated protocols, and the security considerations that come with its implementation. SSO authenticates a user once and then grants access to multiple applications or services without repeated authentication. Thus, when a user enters their authentication information, it is stored and used by various services. This is achieved through the use of tokens. Most likely, you are familiar with cookies that store information about your login information. SSO works similarly. The initial authentication establishes who you are and furnishes you with a token. This token is an all-access pass to all your services. There are two different methods for achieving this. First is centralized SSO. This is a single server referenced by all the applications when they wish to authenticate access requests. A source that establishes user identities is known as an identity provider, or IDP. Say a user first authenticates with this single source, which establishes his or her identity. All other services a user might use hereafter refer to this central source to verify the user's identity. Consider a scenario where you join a new company and receive an ID card. This card might give you access to all company services, such as the canteen, the car park, and the office building. Perhaps it is even linked to gaining access to your computer. A digital example of this is the use of a Microsoft account. Once you have created an account and established your identity, you can use this to access email, OneDrive, Xbox Live, and so on. This streamlines the user experience, reducing the burden of remembering and entering multiple credentials. Another SSO method is federated SSO, where various sources disperse authentication activities. In this case, there isn't a single IDP, and users are allowed to create identities using several IDPs. Having created an ID, a user may wish to access another external service. When the user accesses the new service, it redirects the login to the original IDP to verify that the user is genuine. This way, a user only needs to create one identity and access code, which can be used on different sources. Let's take the company ID card analogy again. This time, it extends to an external conference. So, by establishing authentication using the company ID card, the employee can access the conference buffet. A digital instance of this is Microsoft Entra ID, which allows users to create one identification that can be used with different services. One of the primary advantages of SSO is the alleviation of password fatigue. Users no longer need to keep track of numerous passwords for different systems, simplifying the login process and enhancing the overall user experience. This also leads to better security. Take the common practice of using a pattern for multiple passwords, such as a combination of birthdays and names. Once the pattern has been identified, multiple passwords might be compromised. Besides, learning one strong, safe password is far easier than retaining several simple ones. Additionally, SSO enables organizations to enforce consistent access policies across various platforms, ensuring uniform security measures are in place. Several protocols underpin the functionality of SSO, including Security Assertion Markup Language or SAML. A widely adopted solution, it utilizes XML-based assertions when exchanging authentication data. XML, or Extensible Markup Language, simplifies data sharing between identity providers and service providers. OAuth, which stands for Open Authorization, is often used for authorization, determining when and to what degree access should be granted to a resource. Lastly, OpenID Connect, or OIDC, builds on OAuth and is concerned with storing identity information to verify it against new login requests. These protocols facilitate secure authentication and authorization processes across disparate systems, enabling seamless resource access while maintaining robust security controls. Understanding these protocols is essential for implementing SSO effectively within an organization. While SSO offers significant convenience and efficiency, it also introduces security issues. On the one hand, SSO empowers a user to create a single complicated password that is difficult to crack. A company can significantly benefit from such enforced security policies. However, it is also a single point of failure. For example, say you have federated access to other services via your Instagram account and it gets hacked. This could provide a gateway to hack your other linked accounts as well. Robust authentication methods such as multi-factor authentication are crucial for safeguarding SSO credentials and preventing unauthorized access. Organizations must also be vigilant for potential risks such as credential theft or unauthorized access to sensitive information. As an aspiring IT professional, your future tasks might include implementing strong company policies to address these challenges. This video explored the concept of single sign-on or SSO and its role in simplifying access practices. You now know how one password can secure access to many accounts. However, implementing SSO effectively to ensure a secure user experience requires a comprehensive understanding of its mechanisms and associated risks. By understanding how SSO works, its benefits, protocols, and security implications, you are now better positioned to capitalize on its advantages and plan for potential pitfalls. Many businesses possess varying levels of company data and resources. A common challenge is providing granular access control to regulate access within organizations effectively. Access control is a defensive strategy that IT specialists employ to regulate who can access specific resources or information within an organization and what they can do with it. This video explores various access control models, including discretionary access control or DAC, mandatory access control or MAC, and role-based access control or RBAC. Additionally, you will gain insight into privilege management, focusing on controlling access to sensitive resources and privileged accounts to mitigate security risks. Let's start with why these measures are essential. Robust access control and privilege management are key to preventing unauthorized access, mitigating insider threats, and safeguarding data integrity. It can also limit the fallout from a security breach. So, access control can be a valuable addition to an organization's defensive posture by limiting the scope available to individuals to access company resources. Organizations can implement several types of access control models to manage access to their systems and data. One standard model is discretionary access control or DAC, where the resource owner can control who can access it and what permissions they have. Mandatory access control or MAC, on the other hand, is based on a predefined set of rules set by the system administrator, restricting access based on security levels or classifications. Role-based access control or RBAC is another widely used model that assigns permissions to users based on their roles within an organization. This model simplifies access management by grouping users with similar job functions and assigning them the same permissions. RBAC can help a company manage access rights more centrally. Instead of maintaining oversight of each employee, they can monitor groups. Employee status and access rights are automatically altered with their role in the company. Next, let's discuss privilege management, which is often coupled with RBAC as different roles have different privileges. Privilege management involves defining and managing privileged accounts with elevated permissions, because if misused, these accounts can compromise a system. Privilege management targets more sensitive resources and data to reduce the risks of unauthorized activities and data breaches. For instance, the admin role on your PC has privileged permissions. Before installing software or accessing certain areas, your computer will prompt you to enter an admin password. This leads to another key access control concept you should understand: least privilege. Least privilege is a policy where companies will only grant an employee the amount of access required to perform a task and no more. Another aspect of least privilege is that once the task is done, the user gives up access to the service or resource, which makes the environment more secure. In a privilege management environment, entities with elevated privileges are tracked more closely. If any actions deviate from the expected norm for these accounts, their access can be limited or even removed. Privileged accounts are more sensitive to triggering MFA requests. This video introduced you to access control and privilege management fundamentals. You learned about the different access control models, such as DAC, MAC, and RBAC, and how they help organizations regulate access to their resources. You also gained insight into the importance of privilege management and how RBAC can help administrators implement privileged access policies. Finally, you learned about a subset of privileged access called least privileged access, which only grants users the minimum access required to execute a specified duty. Effective access control and privilege management are essential for maintaining the security and integrity of digital environments. It helps organizations prevent unauthorized access, reduce the risk of insider threats, and protect sensitive data from unauthorized disclosure or modification. You should now have a solid foundation on how reducing and prioritizing access to company resources can effectively safeguard without adversely impacting users' ability to execute their tasks. Mobile phones provide people with numerous conveniences, such as map features, access to social media, and productivity apps. In fact, mobile phones have become essential companions. Keys, cards, and mobile phones are the standard checks when leaving the house, right? Users install various applications daily, ranging from work-related tools to entertaining games, each with its own set of functionalities and permissions. Employees also use their mobile devices to access company networks while on the job. But have you ever stopped to consider the significance of the permissions these applications require? This video focuses on that very topic, exploring how the permissions granted to mobile apps can directly impact security. It will also discuss how shadow IT can pose a considerable risk to an organization with otherwise strong network defenses. Let's jump right in by defining application permissions. Application permissions refer to mobile apps' access requests to perform certain functions or access specific data on the device. These permissions might be necessary for apps to function properly, allowing them to interact with various device features such as the camera, microphone, contacts, and location services. Some typical application requests are location requests used to track your whereabouts for navigation, weather updates, or location-based services. Requests to access contacts are also common. These ask for access to your contact list, potentially used for social media features or sharing contacts. Then there are also camera requests. These allow apps to take photos or videos to capture memories, do video calls, or have augmented reality experiences. Similarly, microphone requests enable audio recording and are used for voice calls, voice assistants, or dictation features. And storage requests provide access to internal storage or SD cards, which are used for storing app data, downloaded files, or media content. There are many other types of requests, which may include access to sensors, calendar events, or even other apps, depending on the app's functionality. With so many request types, users should know about the security risks. Take an example of an application that provides dictation features that will request access to your microphone. This makes sense as it is required for interaction. However, a calendar app generally does not need access to your microphone to function. So, if such a request arises, it is a red flag. An application asking for carte blanche permissions should be handled with extreme care. It is important to remember that not all applications are created to provide you with a service. Any application you install on your phone could have been created by a malicious actor, an individual, or a group that seeks to harm computer systems or networks. Let's go over a few risks involved. Granting access to personal data, such as contacts or photos, can lead to privacy breaches. Malicious actors can use this information to circumvent security measures and gain access to a network. Some applications can mimic established applications with slight variations in logos and brand names. Usually, these apps try to sell services that are otherwise available for free or to install malware on devices. As a consumer, you are free to choose the apps you use. However, app-related risks are particularly salient if you use your mobile device for work-related activities. For instance, malware can gain access to a company network and have major negative repercussions. Employees have the responsibility to be conscious of actions that might affect the security of company data. Let's move on to shadow IT, which refers to using information technology systems and resources outside the official IT department's control. This can include employees using personal devices for work, subscribing to cloud services without approval, or developing their applications. While it offers flexibility and agility, shadow IT can pose security risks, compliance issues, and data privacy concerns due to a lack of oversight and management. An IT specialist must balance encouraging innovation and ensuring security by implementing clear policies, promoting communication, and offering approved alternatives to meet user needs. It might be tempting for employees to use a company device outside work hours. However, it creates a potential exposure and increases the risk of compromise through leaking sensitive data or installing malware. Next, let's discuss unintended risks. In addition to dangers presented by unscrupulous application developers, poorly created applications can also introduce security vulnerabilities. For instance, an insecure API can be a backdoor entry point for a hacker. An API, or Application Programming Interface, enables two programs to communicate, but can become insecure if certain security standards are not adhered to. Some threats that can hide inside an API include code logic flaws, weak authentication rules, weak session management, and insecure server configurations, to name a few. Another security issue might be storing or sending information in an unencrypted form, or sending unnecessary information that the user would want to keep private. Knowing about these security risks highlights the importance of researching any application before installing it on your devices and scrutinizing app permissions before granting access. Some apps may request more permissions than necessary for their intended functions. This should be an immediate red flag about their intentions or indicate a lack of due care and diligence in app development. To mitigate security risks associated with application permissions, users should follow best practices such as regularly reviewing app permissions, limiting access to sensitive data, and avoiding granting unnecessary permissions. Additionally, users can enhance their device security by installing security updates, using reputable app stores, and implementing robust authentication methods. In this video, you learned that tracking mobile device application permissions is crucial. Applications can pose intentional risks or inadvertently through poor development. And although IT departments can review and sanction some applications, employees using shadow IT create a backdoor for threats. By understanding the significance of application permissions, employees can make informed decisions when granting access to mobile apps and protect themselves and the networks they use from potential security threats. Imagine that an employee has downloaded a file on their company-issued laptop, only to find that the computer lacks a program capable of opening it. An online search produces a promising free application, and the employee decides to install it. While this may seem like a routine task, acquiring software from unreviewed sources actually carries risks. To minimize exposure to potential threats, such a duty is best handled by an IT professional. Installing software onto a computer means adding code that someone else wrote to the environment. Therefore, ensuring that the code you're installing performs how you expect is paramount. This video aims to provide a comprehensive understanding of the critical principles of secure software installation, emphasizing the importance of following best practices to ensure the integrity and security of digital environments. By completing this video, you will gain insights into the dangers of installing poorly vetted software. In addition, you will acquire steps that you can employ before every installation, helping to ensure the integrity of your company's security. Let's start by discussing the importance of installing software securely. Software vulnerabilities can grant attackers access to systems, allowing them to steal data, disrupt operations, or launch further attacks. Installing software securely minimizes these risks by ensuring the software is legitimate, its permissions are controlled, and configurations are secure. Innumerable instances have highlighted the importance of treading carefully when installing software. For instance, a popular target for hackers is cryptocurrency. It is easy to move, untraceable, and means an immediate payday. Users who installed a wallet with vulnerabilities due to lax installation practices suffered a massive loss in 2023. Hackers exploit these flaws, siphoning millions of dollars worth of Bitcoin from unsuspecting users who had installed the wallet without due care. In another major incident, a hospital that failed to vet and install medical software properly allowed the installation of the virus WannaCry and became vulnerable to a ransomware attack. Attackers encrypted critical patient data, holding it hostage in exchange for hefty ransoms, jeopardizing patient care and potentially putting lives at risk. This virus spread to many hospitals and seriously disrupted the operations of providing medical treatment for the ill across several countries. While cryptocurrency theft and healthcare data breaches highlight the dangers of insecure software, the threat extends far beyond specific industries. In our homes and workplaces, we increasingly use smart devices. Neglecting secure software installation exposes any device and its connected data to potential compromise. Hackers can exploit vulnerabilities to steal everything from personal information to critical infrastructure data, causing financial losses, operational disruptions, and physical harm. Devices can be repurposed as part of botnets, and privacy can be violated through hacking camera and microphone capabilities. A botnet is when your device is added to a group of other hijacked devices controlled by a hacker to do some task without the owner's knowledge. Remember, every unsecured device becomes a potential entry point. Exposing one device without proper care can lead to a compromise that spreads to all devices. To ensure secure software installation, it is essential to follow best practices that help minimize potential risks. Verifying the authenticity of the software source is a critical step in preventing the installation of malicious or compromised software. Here is a checklist of considerations to make before downloading and installing any external code. First, always download software from the official developer's website or a trusted repository. Downloading from untrusted sources increases the risk of malware-infected software. A web search on a given software application before installation will reveal reviews and any warnings that might be associated with it. Next, closely regard the permissions requested during installation. Only grant necessary permissions and avoid giving administrative privileges unless essential for running the program. A software installation process that includes requests for more permissions than is required for its tasks is a red flag and should be treated cautiously. You'll also want to ensure that your system meets the software's minimum requirements before installation. Insufficient resources can lead to software instability and potential vulnerabilities. Recall that overflowing a computer's buffers is an established means of gaining illicit access. Enable User Account Control, or UAC, is a Windows feature that prompts for confirmation before making system changes, preventing unauthorized installations. You will have administration rights on an employee's laptop as an IT professional. Ensure the user's account does not allow them to install software before consulting with you. Antivirus and anti-malware software can detect and block malicious software attempts during installation. This can be a valuable measure as new software brings different behavior, which can make it easier for malware to slip in unnoticed otherwise. Finally, you should regularly update software to patch vulnerabilities identified by developers. Ideally, you should enable automatic updates whenever possible. Software, when initially released, will always contain flaws and vulnerabilities. As software matures, these are discovered and documented, and patches are created. Always install a new patch when it becomes available. In this video, you discovered why secure software installation is critical to maintaining the security and integrity of a company's cybersphere. By following best practices, verifying software sources, understanding permissions, evaluating requirements, and avoiding untrusted sources, users can enhance system security and protect against potential threats. This video gave you a comprehensive overview of the fundamentals of secure software installation, equipping viewers with essential knowledge to safeguard their systems effectively. Imagine that you've installed the perfect application that does everything you need it to do. When you receive a prompt to install an update, you decide to ignore it. After all, why mess with perfection? However, such a decision is not without risk. To find out why, let's establish what exactly a software update is. Fundamentally, an update is an optional change that software users can apply to their existing software installation. These could add new features, or they could be added protection measures for your system. In this video, you'll explore the significance of software updates and why they are crucial for security. Expect to learn about the types of updates available and the effect they have on system security and performance, the software update lifecycle, and the possible consequences of neglecting updates. By better understanding the role of updates in addressing vulnerabilities and enhancing system performance, you might think twice before postponing that update request indefinitely. A software update can come in different flavors, each addressing a software user's needs. Broadly speaking, it is possible to separate two functional categories, each fulfilling a distinct user need. One is maintenance updates, which encompasses bug fixes and security updates. These updates are essential for maintaining the software's stability, functionality, and security. They address issues, errors, and vulnerabilities within the software, preventing crashes, unexpected behavior, and potential security breaches. The other is enhancement updates, which include both feature updates and performance enhancements. These updates focus on improving the software's user experience and overall capabilities. They introduce new functionalities, features, and performance optimizations, making the software more powerful, efficient, and user-friendly. So how exactly are these changes implemented? Maintenance updates are achieved through the use of patches. A patch is a targeted software update that addresses specific bugs, security vulnerabilities, or minor functionality issues within a program. Patches are designed to be small and focused to quickly resolve problems without significantly altering the software's core features or user experience. In contrast, more extensive updates often introduce major new features, significant performance enhancements, or even wholesale overhauls and redesigns of the software. These are typically released as new versions or major updates, clearly distinguished from smaller patches. Patches can further be distinguished by whether they are a hot or cold patch. Let's examine the differences between them. A hot patch takes effect without interrupting or restarting the running system. It acts like a quick fix, addressing issues like minor bugs or security vulnerabilities without impacting ongoing operations. Hot patches are advantageous as they minimize downtime and ensure service continuity, especially in critical environments. However, their application may be limited in scope and complexity due to the need to avoid disrupting the running system. In contrast, a cold patch requires the system to be restarted for the update to take effect. Any running services or applications will be interrupted during reboot, leading to potential downtime. While cold patches can address a broader range of issues and implement more complex changes than hot patches, their application requires careful planning and scheduling to minimize disruption to users and ongoing processes. Understanding the software update lifecycle is essential for grasping how updates are developed and released. Software developers continuously monitor for product vulnerabilities and release updates to address these issues. The optimal outcome is that the in-house developers discover and address the flaw immediately. However, often it will be found by a member of the public. Companies will often offer bounties to encourage people to report flaws. A bounty is paid when a public member finds, documents, and reports a flaw. A company will pay the finder and create a fix. This proactive approach helps to ensure that software remains secure and reliable. However, a hacker sometimes discovers a flaw and intends to use it for nefarious reasons. Instead of reporting the issue, they exploit it to gain access or disrupt the operations. In these events, the fingerprints of the hacker are traced, and when the point of entry is identified and closed, the company will issue a patch to be deployed on existing instances of the software. By staying informed about the software update lifecycle, users can decide when to apply updates to their systems. Real-world examples of security breaches resulting from outdated software are a stark reminder of the importance of timely updates. High-profile incidents like the Equifax data breach have been attributed to unpatched software vulnerabilities. These incidents underscore the critical need for organizations and individuals to prioritize software updates as a key security practice. The WannaCry virus was discovered to have gained entry by accessing TCP port 445. The Server Message Block, or SMB protocol, uses this port, which allows for file sharing and remote administration between Windows computers. The patch removed unauthorized access to this port, making the attack ineffective to updated machines. In this video, you discovered why software updates are an important step in safeguarding and optimizing the computer network. Understanding the types of updates, the software update lifecycle, and real-world examples of security breaches highlights the importance of prioritizing software updates as a crucial practice in IT security. By regularly applying updates that address security vulnerabilities, users can reduce the risk of security breaches and protect their data effectively. Stay informed, stay secure. As a business operating online, your company may find certain duties, such as processing payments or managing customer relationships, to be difficult or inefficient when done manually. Third-party software that is specialized for such tasks, often customized to meet specific company needs, offers an appealing solution to this problem. However, you should be aware that integration of external software means enabling access to certain company systems and data, and should be done with an abundance of caution. In this video, you'll become aware of key security considerations when integrating third-party software into existing systems. While such integration can enhance functionality and efficiency, it also introduces security risks that require careful management. You will explore these potential risks and become familiar with effective identification and mitigation strategies. As part of an IT organization, you may install libraries and programs created by others. These can assist in quickly creating bespoke solutions to address business needs. However, note that Integrating third-party software necessitates awareness of the accompanying security risks. One primary concern is the presence of vulnerabilities within the third-party code itself. Malicious actors can exploit these vulnerabilities to gain unauthorized access to the system or compromise its integrity. One way hackers have done this is by installing a hot rat, which is a remote access Trojan, on the systems of users who mistakenly believe they got a good deal. Hot rats are software programs that reside in cracked versions of reputable software. Cracked software is when someone circumnavigates the developer's security and makes the software available for free. Hackers tweak the original software to bypass the licensing issues, and when you install the cracked version, you also get their software. Consider the malware as the trap and the tempting free software the bait. Hot rats are designed to log your keystrokes, copy your files, and even give access to your system. A robust security strategy is essential to mitigate security risks associated with third-party software integration. This strategy should encompass several measures, including vetting third-party vendors to ensure they have a strong security posture and a secure software development track record, conducting thorough security assessments to proactively identify and address vulnerabilities in the third-party software before integration, and continuously monitoring the integrated software for security incidents or anomalies to detect and respond to potential threats before escalation. You will also want to implement access controls, encryption, and intrusion detection systems to further enhance integrated software security and protect against potential attacks. Another important step is dependency tracking. This entails maintaining an inventory of all dependencies used in the software development process. This includes libraries, frameworks, and modules. Keep track of their versions and any known vulnerabilities associated with them. A best practice is to stay updated with the latest versions of dependencies. Developers should regularly check for updates and patches released by the providers of the dependencies. Updating to the latest versions helps mitigate known vulnerabilities and security issues. Finally, you should establish a policy for approving and using dependencies. Only allow the use of dependencies from trusted sources that have undergone thorough security assessments. Maintain a white list of approved dependencies to reduce the risk of introducing malicious or vulnerable components into the system. In this video, you discovered how integrating third-party software offers increased functionality, but also introduces security risks that demand careful management. By effectively identifying and mitigating these risks through thorough security assessments, vendor vetting, and ongoing monitoring, organizations can safeguard their systems against potential security threats. Prioritizing security throughout the integration process is crucial to ensure the integrity and safety of your digital environment. Whenever you install software, you increase the surface area of attack on your organization. While you can mitigate some of these with good practices, it is also important to train every staff member on good security protocol, not just the IT department. You are likely familiar with cyber attacks that target an organization directly by means such as attempting unauthorized entry or deceiving users into installing malware. However, hackers may also exercise less conspicuous but equally damaging methods. In this video, you will be introduced to supply chain attacks, a cyber threat where attackers compromise legitimate software or its delivery process to distribute malicious software. As you'll observe in several real-world examples, these attacks can significantly impact software installation by going undetected and posing severe risks to users and organizations. However, you'll also arm yourself with best practices for mitigating the risk of such attacks. By understanding the nature of supply chain attacks, individuals can better protect themselves and their systems from potential harm. When safeguarding an organization, the immediate thought is to monitor the points of entry a hacker may utilize. While this is a solid approach for maintaining work devices and the company network, another potential danger is that an element of your supply chain is compromised. Like its army namesake, a supply chain is a company's nourishment source. This analogy refers to the company's dependencies and third-party libraries used when creating its products. A supply chain attack is when a hacker infiltrates the vendor's network and install their compromised software unknowingly. It is a particularly nefarious attack and can come from any trusted means, including updates and hot patches from trusted vendors. Recent examples of supply chain attacks have demonstrated the potential dangers they pose. Attackers have been able to infiltrate software vendors and insert malicious code into legitimate software updates, leading to widespread infections and data breaches. These attacks can be challenging to detect, as the compromised software appears legitimate and may not trigger traditional security measures. As you will observe in the following examples, some attacks find malicious software getting onto devices before they reach end users. For instance, in 2012, malware was discovered pre-installed on a substantial portion of devices distributed by a major US software company, highlighting vulnerabilities in the distribution chain. In another case in 2016, a foreign company embedded software in the cell phones of American users, clandestinely transmitting sensitive data to external servers regularly. Other attacks may target networks that then reach connected users. SolarWinds, a prominent IT management firm, fell victim to a sophisticated attack in 2020 where adversaries compromised its build servers to inject malicious code into software updates, compromising numerous customer networks. While in 2017, allegations surfaced regarding an overseas antivirus vendor's collusion with a foreign intelligence service, prompting the removal of its products from US government networks. Finally, an examination of discarded electronic devices in 2019 revealed widespread mishandling of personally identifiable information, underscoring the broader implications of supply chain vulnerabilities. It's tough to mitigate against this type of attack, as common protective measures may not help. Many defensive strategies involve establishing trust with external sources before granting access. However, these attacks are executed on entities already vetted by the system. In addition, good security practice involves allowing regular updates. To mitigate a supply attack by refusing updates allows one to fall prey to other attacks that a potential patch aims to mitigate. In other words, the goal of these attacks might be to prevent important updates from reaching a company, leaving them vulnerable to another attack. One step that can reduce these approaches is maintaining the least privileged access policy. Any software operating on your system should have only the minimum access to execute their task. This will reduce the potential fallout from a supply chain attack that has gained access. It is paramount to vet software sources to ensure they are legitimate and trustworthy. This includes selecting partners known to pay diligent attention to good security hygiene. Many third-party organizations have developed best practices when it comes to safety. Honors such as the Cybersecurity Excellence Awards, Info Security Products Guide, Global Excellence Awards or SC Awards are indicators of companies that regularly employ strategies such as the software development lifecycle, regular code reviews, detection and isolation of weaknesses and vulnerabilities, and active reporting of any exploits as discovered. Other signs of strong security practices include active monitoring for unusual software behavior that may indicate a compromise and staying current on software security updates and patches. By taking these proactive measures, companies can reduce their vulnerability to supply chain attacks and protect their systems from potential harm. In this video, you found out that even the most secure defensive strategies will always expose some element of your company, and it is nearly impossible to avoid all dangers. A supply chain attack poses significant risks to software installation and can have severe consequences for users and organizations. It is difficult to detect and difficult to offset. Awareness on the nature of these attacks will highlight for you that constant adherence to best practices for software security is paramount. There is no such thing as over-vigilance. You've arrived at the end of the first module of this course, and you've already acquired quite a bit of knowledge when it comes to installing, configuring, and regulating access to software. Before you move on, let's review the essential topics that you learned about. And if anything sounds a little hazy, you may want to take the opportunity to revisit previous content before you take on the module quiz. You started off the week with an overview of software security and developed a general understanding of software vulnerabilities, security threats, and strategies for staying safe. You then went in depth into the End User License Agreement, or EULA, a contract that specifies the terms of use for a software program. Here, you became familiar with the type of information typically found in EULAs, such as usage rights, limitations, warranties, and liabilities. You also discovered that ignoring the terms of a EULA carries both legal repercussions, such as fines, and security consequences, like the misuse of personal data. Next, you explored the different types of malware, which is malicious software intended to harm systems or networks. You found out how to differentiate between viruses, Trojans, and worms, which includes identifying their unique characteristics, methods of spreading, the potential damage each can cause, and the implications for security. Fortunately, as you later learned, there are tools for defending against such threats. You were introduced to software firewalls, which monitor incoming and outgoing traffic and block or allow movement based on alignment with security rules. And you became aware of antivirus and anti-malware applications, which are able to detect and remove suspected malware. From here, you shifted your focus to access control and privilege management, which are means of regulating who can access specific applications and data. You began with an outline of common user authentication issues, such as locked accounts, troublesome password recovery processes, and challenges with multi-factor authentication. You then segued into the concept of single sign-on, or SSO, a method for accessing multiple services with a single set of credentials, also solving many of the aforementioned problems. Following this, you became aware of access control and its significance in protecting sensitive information. You explored different access control models, namely discretionary access control, mandatory access control, and role-based access control. This strategy is often supported by privilege management, which involves defining and managing the rights and permissions of users and systems within a network. To further enhance your understanding of these valuable tools, you examined a few examples of how they are applied in real-life scenarios. In the final part of this week, you took a comprehensive dive into the importance of secure software installation for maintaining safety. This started with the critical role of software updates. You found that beyond adding or enhancing features, updates also fix bugs and eliminate vulnerabilities that could otherwise be exploited by attackers. Users can stay safe by applying updates regularly, ideally by making it an automatic process. You were then made aware of common mistakes that users make when installing software, such as not checking system compatibility, ignoring user agreement details, and bypassing custom installation options that might lead to unwanted software components being installed. These issues can be avoided by practicing vigilance and awareness and knowing what exactly you are adding to your system. You also discovered the risks associated with integrating third-party software into existing systems, which include vulnerabilities in third-party code or dependencies and vendors with a poor security record. And finally, you were introduced to supply chain attacks, a particularly nefarious cyber threat that targets weaknesses in the process of third-party software being delivered to businesses and organizations. But on top of learning of these dangers, you were also familiarized with strategies for safeguarding your system or network. These include verifying software authenticity, acquiring programs only from official or approved sources, being wary of unnecessary bundled software, and using antivirus or anti-malware programs for added protection. Nice job navigating through this introduction to configuring and using software with personal and organizational safety in mind. With this knowledge, you have taken another step in your journey to become a security-minded IT professional. Chances are you're familiar with the inner workings of a computer, a complex network of wires and components. Have you ever wondered how pressing the power button initiates a process that wakes up all your machine's hardware and software components? It all starts with the basic input and output system, or BIOS, a crucial element of computer systems that initializes hardware components and facilitates the boot process. The BIOS ensures a computer starts up properly and effectively interacts with its hardware. Understanding the basic functions and significance of BIOS is essential for anyone working with computer systems. This video provides an introduction to the BIOS. You will also learn about later developments in Unified Extensible Firmware Interface or UEFI and the importance of complementary metal oxide semiconductor or CMOS batteries. Don't worry if these terms are completely unfamiliar. In the next few minutes, you'll gain a clear understanding of these components. Originally, BIOS was a simple program stored on a ROM chip on the motherboard. It provided basic instructions for the computer to start and load the operating system. So, when you press the Start button, the BIOS checks that the essential hardware is connected and available for operation. Imagine a pilot doing pre-flight checks and flipping the appropriate switches. Over time, BIOS has evolved to adapt to changing hardware and software requirements. New challenges include ever-increasing capabilities and requirements in computers, such as greater architectures, network booting, and greater security measures against hijacking, to name a few. This has led to a migration away from using BIOS. Modern systems use a Unified Extensible Firmware Interface, or UEFI, to replace traditional BIOS. UEFI offers enhanced features and capabilities, such as support for more extensive storage devices and improved security measures. Often, both systems exist on a computer. However, the UEFI is the most efficient boot-up option. Back to BIOS. The BIOS is an example of firmware. Firmware, much like a driver, is a small piece of code that lies in the center of a device embedded at the time of manufacture. The distinction between firmware and a driver is that firmware is the prime directive for the devices. It includes the instructions that determine how it will behave. In contrast, the driver's role is to enable interaction between different devices or between the operating system and the device. Think of it as an adapter that allows you to use your electrical plug in different environments. Now you might wonder, how can the BIOS start if the computer is still off? The BIOS is stored on the ROM, which, as you might know, is the non-volatile memory storage of a computer. During the initial boot-up stage, the BIOS checks what hardware components are connected, such as a keyboard, speakers, mouse, and so on. It will activate these, retrieve the operating system from the hard drive, and load it into RAM, which is volatile memory. Once this is complete, the BIOS will hand control over to the CPU. It might be helpful to think of the BIOS as a secretary for a busy manager. On entering the office, the secretary informs the manager of all the appointments, updates, and actions required. The manager uses this information to form a plan of action for the day. Next, let's discuss another crucial component for the functioning of the BIOS, the CMOS battery. The complementary metal oxide semiconductor, or CMOS battery, is a small, coin-shaped battery on the motherboard that powers the CMOS memory chip. It is used in memory chips, computer processors, and other electronic components. The CMOS chip is a low-powered, reliable device for storing information. This chip holds the BIOS settings, including the system clock, hardware configuration, and other essential parameters. The CMOS battery maintains these settings even when the computer is turned off. If the CMOS battery fails or weakens, it can lead to incorrect system time, hardware detection errors, and instability. Maintaining a functional CMOS battery is crucial for system stability and performance. In addition to storing information, it can regulate power flow. Without a working CMOS battery, the BIOS settings may reset to default values each time the computer is powered on, causing disruptions in system operation. Regularly checking and replacing the CMOS battery when necessary can help prevent potential issues and ensure the BIOS functions correctly. Another factor that can affect CMOS integrity is overclocking. This is when excessive strain is placed on a computer by over-optimizing it. Let's unpack what this means. One can increase the clock speed of a computer to speed up information processing, but it comes with considerable risks. In addition to potentially damaging your RAM and CPU, it is a hazard to CMOS batteries. It's best not to tamper with this. In this video, you learned that BIOS plays a critical role in a computer's boot process and hardware initialization, while the CMOS battery preserves vital BIOS settings. And UEFI is a more modern and efficient boot-up option. Understanding the basic functions and importance of BIOS is essential for anyone involved in IT security and data management. With this knowledge, you can effectively manage computer systems and ensure optimal performance. Early computers relied on the basic input-output system, or BIOS, to start up and operate safely. However, ever-improving computer capability and reliance also spurred advancements in the boot-up process. Understanding the transition from legacy BIOS to UEFI provides insights into computer fundamentals and will aid in succeeding as an IT professional. This video outlines the evolution of the BIOS to the Unified Extensible Firmware Interface, or UEFI. You will gain insight into the advancements in firmware technology and its implications for system security and functionality. The traditional role of the BIOS is to activate all hardware devices, load the OS into RAM, and perform a sequence of power-up tests. UEFI encompasses these interactions but represents a more advanced and modern approach to firmware technology. UEFI offers enhanced features, improved security benefits, and better performance than legacy BIOS. While both systems may exist in tandem on a computer, it is more efficient to use the UEFI to coordinate preferred startup settings. One notable advancement of UEFI is that it enables more complex booting architectures. To boot successfully, the booting architecture must locate and initialize the necessary components on your computer's hard drive to load the operating system and prepare the system for use. Visualizing your hard drive as a filing cabinet with related components compartmentalized in different drawers will help you understand this process. Traditionally, the Master Boot Record, or MBR, served as a crucial component in booting architecture, containing essential information about the disk's partitions and the bootloader's location. However, MBR operates on a 32-bit architecture, limiting it to a maximum of 4 partitions and compatibility with BIOS. In contrast, modern computer systems typically employ a 64-bit architecture, allowing for larger storage capacities and more partitions. Consequently, they often utilize the GUID partition table, or GPT, for disk partitioning and management. Unlike MBR, GPT offers support for larger disk sizes and virtually unlimited partitions, aligning with the expanded capabilities of modern systems. UEFI firmware is specifically designed to work seamlessly with GPT partitions, offering better compatibility and functionality compared to BIOS systems. Next, let's discuss another great functionality of UEFI: Secure Boot. This technology uses cryptography to create unique keys for processes, reducing the risk of unauthorized access and ensuring the integrity of the boot process. You might have noticed that when downloading software, you can find the developer's signature key for that software. It's good practice to verify that the developer key matches the downloaded software before installing it. Secure Boot works in the same way. Using a public key infrastructure, or PKI, each reputable startup process has its key, which is verified before initiation. So, because only trusted software is loaded during the boot process, it prevents malware attacks. It also allows for faster boot times, improving overall system efficiency. However, despite this focus on security and verification, Secure Boot does not restrict users to only using pre-approved software from known developers. It still allows you to develop your own kernel or startup process. You can submit your own software to UEFI to be included in the startup verification process, allowing your custom software to launch securely along with other recognized programs. Moreover, UEFI is compatible with modern hardware, allowing seamless integration and improved system performance. Common examples of modern hardware that benefit from UEFI's capabilities include the latest generation of GPUs, high-frequency RAM modules, and advanced multi-core CPUs, all of which are crucial for maximizing the performance of high-demand applications and gaming systems. There are also better diagnostic capabilities during power-on, self-test, and remote management. When a computer starts up, UEFI performs detailed checks on hardware and software. If an error is detected, UEFI provides specific error codes and a more comprehensive diagnostic report compared to traditional BIOS systems. This helps IT support staff quickly understand and resolve issues without needing physical access to the machine. What's more, UEFI supports Advanced Encryption Standard or AES so that IT administrators can remotely interact with an employee's computer. For instance, if an employee's laptop becomes compromised with malware that prevents normal startup, an IT administrator can securely boot the system into a safe recovery environment over a network to troubleshoot and fix the issue, all while ensuring that the interaction is protected by strong AES encryption. This video walked you through the development of BIOS to the more advanced UEFI. You learned that with the transition from legacy BIOS to UEFI, the boot process gained additional functionality, became more secure, and allowed for greater compartmentalization of startup processes. Other UEFI improvements over legacy BIOS includes secure boot for preventing unauthorized access, modern hardware compatibility, better diagnostic capabilities, and Advanced Encryption Standard or AES. UEFI presents a significant advancement in firmware technology, offering improved security, functionality, and performance for modern systems. Understanding the boot process requires knowing the difference between BIOS and UEFI as well as the implications of the transition. This knowledge can help IT professionals to safeguard company devices and manage data effectively when troubleshooting issues. Unified Extensible Firmware Interface or UEFI has become the new industry standard for boot-up firmware due to its enhanced system security and functionality features. Keeping UEFI updated is crucial to maintaining the effectiveness of these security features. However, adjusting specific setup options can further enhance these security features. This video explores adjusting specific UEFI setup options to enhance protection against unauthorized access and potential threats. If you are a Mac user, this process does not apply because Macs do not use BIOS. They use UEFI, which automatically updates with firmware. To begin, knowing where to find the UEFI interface is essential. On a Windows machine, follow these steps. First, select the Start or Windows icon in the taskbar. Then, select the Settings utility, represented by the gear icon. Next, select System in the left-hand panel. Scroll down the list and select Recovery. Under Advanced Startup, select Restart Now. In the new window, under Options, choose Troubleshoot. Then select the Advanced option. Next, select UEFI Firmware Settings. And finally, select the Restart option. Here, you can adjust a range of UEFI settings that provide granular control over various system aspects. You can modify the UEFI settings depending on your device. For instance, the options for a Microsoft Surface device range from boot configuration to system logs. Other options include security, power, password, and display options. Take the time to investigate each of these options on your system. Let's discuss a few salient ones. First is boot order. This setting determines the sequence in which your system attempts to boot from available devices such as a hard drive, USB drive, or CD-ROM. At this point, the UEFI is trying to install an operating system. By assigning an order of priority, you reduce the risk of an alternative location being selected. This can thwart attempts to boot from unauthorized devices, such as from a USB stick. Next is Secure Boot. This security feature verifies the digital signature of bootloaders and operating system kernels before allowing them to execute. You can locate this under Boot Configuration. Secure Boot helps prevent malicious code from loading during the boot process, potentially mitigating malware infections. Creating digital signatures is an established method for protecting users against tampering with legitimate software and processes. Let's discuss two more features: Admin Setup Lockout and Master Password Lockout. These features work together to safeguard your system's core configuration. Admin Setup Lockout restricts access to the BIOS setup menu, requiring a password even to view or modify settings. Master password lockout adds an extra layer of protection by blocking methods to reset BIOS passwords like admin or HDD passwords if enabled. Additionally, some UEFI implementations may offer a password bypass option. This security shortcut allows access to the BIOS setup menu without the correct password. However, it completely weakens the security provided by password lockouts. Enable it with the utmost caution, as it defeats the purpose of password protection and leaves your system vulnerable. From this list of customizable settings, it's evident that the UEFI boot process offers fine-grained options to adjust the security levels of devices to fit their purposes. For instance, the configuration for a company device used by employees will most likely differ from the configuration settings for your laptop. The options range from how you wish to start your system to how you would like to enter passwords. UEFI's password options provide a layered security approach to safeguard your system's BIOS settings. Moreover, it allows you to specify password requirements such as uppercase, lowercase, and symbols. While password bypass offers a convenient backdoor, you should only use it in particular scenarios where security is less of a concern. Next, let's discuss the advanced security features often included in modern UEFI implementations. First is the Trusted Platform Module, or TPM, a hardware chip that integrates with the motherboard. It provides secure storage for cryptographic keys used for system authentication and data encryption. TPM can enhance platform integrity and secure boot processes. Second is Secure Attention Mode, or SAM, a security mechanism that isolates hardware interrupts generated by low-level firmware, preventing malicious code from manipulating them. While these advanced features offer additional security benefits, their configuration might vary depending on your specific hardware and may require advanced technical knowledge. As a final note, you can find information about a system on the manufacturer's website, including new versions, motherboard manufacturer documentation, and insights on various configuration choices. Many security professionals on different levels will, at one point or another, be faced with the choice of configuring the security level of their bootup. You can significantly strengthen a system's defenses by familiarizing yourself with UEFI's security settings and implementing appropriate configurations. Prioritizing trusted boot devices, enabling secure boot where applicable, and utilizing password protection for critical functions are all viable options that will harden the accessibility of a system. Hardware firewalls are essential network security components, providing a robust defense against external threats. Just like a gatekeeper at an event only allows access to guests on the list, a firewall controls what comes in and out of a computer network. Any IT professional should have foundational knowledge about basic firewall concepts and functionalities and their critical role in safeguarding network environments. After watching this video, you will be able to describe a hardware firewall and distinguish its functionality from its software variant. You will also learn about concepts like packet filtering, stateful inspection, and demilitarized zones, or DMZ. Let's start by defining a firewall. A firewall is a hardware or software device that protects a network by filtering incoming and outgoing traffic based on a Special Access Control List, or ACL. This list determines which sources are acceptable to receive packets from and which are not. A hardware firewall is a physical implementation of this. It filters incoming and outgoing traffic, serving as a gatekeeper and the front line of defense in preventing malware from taking root in a network. Unlike software firewalls operating within individual computers, hardware firewalls offer a dedicated defense mechanism between the internal network and the internet. This positioning allows for more effective monitoring and control of network traffic, enhancing overall security. You will learn about other differences between hardware and software firewalls later on. Let's zoom in on where and how hardware firewalls operate. Much like a router, a hardware firewall sits at the entrance of a network and routes data packets. But rather than naively routing packets, it filters packets, letting only the safe ones through. Using information such as the ports, protocols, and IP addresses, Firewalls identify which packets should be forwarded and which should not. This service is known as packet filtering. Another valuable function of hardware firewalls is stateful inspection. This feature monitors the state of active network connections, such as the source and destination addresses, ports, and protocols. Let's spend a minute to discuss how this works. When a firewall receives a packet, it checks if it belongs to an established connection listed in its connection table. If the packet matches an existing connection record and adheres to the expected behavior, the firewall will allow it to enter the network. On the other hand, if the packet is unrelated to any known session or violates expected protocol rules, it's blocked. Stateful inspection protects against attacks that attempt to exploit open connections or misuse protocols. However, stateful inspection requires additional resources to maintain the connection table. A third feature of a hardware firewall is a DMZ or demilitarized zone. This location or network segment is positioned between an internal network and the external intranet. Its purpose is to host servers that require public access, such as web or gaming servers, while keeping them isolated from the sensitive internal network. This setup bolsters security by creating a buffer zone. Think of it as a secure lobby in a corporate building. Visitors are required to check in and undergo security checks before gaining access to the main offices, maintaining the integrity of the internal environment. There are various ways to implement DMZs, such as using a single firewall with specific rules or deploying multiple firewalls for even more protection. Researchers also regularly use a DMZ to study malicious attacks. Termed honeypots, these DMZs present themselves as accessible targets on the web. Researchers then analyze the traffic attracted to it. If malware enters the honeypot, they document and store the signature of the attack for greater protection. What about firewall configuration? This involves setting up rules and policies to control inbound and outbound network traffic. The ACL can specify which types of traffic are allowed or blocked based on criteria such as IP addresses, ports, and protocols. By fine-tuning these configurations, organizations can tailor their security measures to mitigate potential risks and protect their network environments. The insights gained from honeypots can direct configuration to ensure that detected malicious traffic is blocked from accessing the system. In addition to seeing where an item is going to or coming from, hardware firewalls can set up filters on inbound and outbound traffic based on protocol or package type. Next, let's revisit the comparison between hardware and software firewalls. Hardware firewalls offer several advantages to their software counterparts, such as single-device network control, meaning that one device can be used to protect entry to the system. Since a physical firewall sits at the entrance to the network, it offers one central location to configure defensive settings. Software firewalls, in contrast, sit on each device, meaning multiple configurations are required depending on the organization's architecture. Second, a hardware firewall is a once-off expense. Like a physical gate, once installed, it continues to work as initially configured and is therefore relatively inexpensive. Software solutions, on the other hand, often require monthly or yearly subscriptions. A third benefit is that hardware firewalls offer better security due to a separate operating system and prevent threats from reaching internal drives. While a software firewall existing on a device can be turned off by an attacker, and this is not the case for physical firewalls. These benefits indicate that hardware firewalls are a comprehensive security solution that effectively safeguards network environments from external threats. However, the intention of this comparison is not to suggest that one should be employed over the other. Instead, the best practice for network defense is using both hardware and software firewalls. This video introduced you to how hardware firewalls function. You learned about its features like packet filtering, stateful inspection, and DMZs. You should also now be able to make a clear distinction between hardware and software firewalls. When purchasing electronic appliances, trustworthy brand names are often advisable. After all, Trust comes from years of supplying devices of good quality that people can rely on. However, you might be surprised to realize that these reputable brand names often outsource the creation of some components to subcontractors. When a company uses components created externally, it is said to use external original equipment manufacturers or OEMs. In this video, you will become familiar with OEMs in the computer world who provide the service of manufacturing and replacing computer components. OEMs play a significant role in the design, production, and security of hardware components, ultimately contributing to the overall protection of digital environments. This video explores their importance in hardware security, shedding light on their measures to safeguard hardware devices. An OEM can be an established company or a lesser-known one. They design and produce components or entire products that other companies incorporate into finished goods. Sometimes, rival companies will even produce components in each other's final product. The acronym OEM was established long before computers powered the term. Typically, it is found in the automotive industry, where many components are shared or outsourced. For example, the Mini Cooper runs on a BMW engine, and the Skoda part of the Volkswagen Group runs on the same engine as the Audi. This might influence your decision-making when deciding how much to spend on your new car. In the computer industry, OEMs create hardware and software components like processors, memory, network cards, operating systems, and more. This means purchasing well-known computer brands may contain internal components designed and manufactured by a different company. A notable example is the Windows operating system. While other companies build their computers, such as Apple with the Mac and Dell with their wide range, Windows has instead always aimed to make an interoperable operating system that can run on any PC. This makes them the OEM of the operating systems. Microsoft expanded from its role as OEM provider with its Surface line range of devices. Intel, a rival PC producer, provides the processors for this range, making them an OEM and a customer, as Intel would incorporate Windows OS in their PC line. OEMs introduce potential security concerns because the company selling you the finished computer doesn't have direct control over every aspect of the hardware's production. For example, a vulnerability discovered in a memory chip sourced from an OEM could leave computers using that component at risk, even if the computer manufacturer themselves is not at fault. To mitigate these risks, it's essential for computer manufacturers to carefully select OEM partners and work closely with them to ensure that all components meet strict quality, performance, and security standards. In addition, an individual procuring computers on behalf of their company should investigate not just the specs of each device, but also the parts that comprise it. This means checking the reputation of both the device provider and the OEMs for evidence of regular testing, auditing, and establishing clear security protocols throughout the supply chain. The security of a device begins at the individual components. Security specialists know that the first port of attack is when a device is starting up. The OS bootloader will load the operating system into memory from storage. A rootkit will attempt to hijack a device at this stage before software protections like anti-malware and firewalls can begin. To prevent this, security measures such as Trusted Platform Modules or TPMs are implemented as safeguards. The TPM is a chip built into the motherboard that verifies that the appropriate operating system has been loaded. This ensures that the device is operating in a trusted environment. OEMs should also bolster hardware security through measures like firmware protection. Firmware, the low-level software that controls hardware, is a potential attack target. OEMs implement safeguards to prevent unauthorized firmware access or modification. Additionally, other security chips like TPMs are integrated by OEMs into devices to provide secure storage for encryption keys and user credentials. A key role of OEMs in hardware security is ensuring that devices meet industry-standard security protocols. This includes compliance with regulations such as the Trusted Computing Group's specifications for hardware-based security, which outline requirements for secure boot processes, encrypted storage, and secure communication channels. By adhering to these protocols, OEMs help guarantee that hardware devices are protected against potential threats. Organizations should purchase hardware from reputable OEMs to ensure that devices have not been tampered with and meet necessary security specifications. By choosing OEMs with a proven track record of prioritizing security in their products, organizations can mitigate the risk of using compromised hardware that could potentially expose sensitive data to security breaches. While there might be a temptation to replace or procure parts that are considered good value, it is of paramount importance that the reputation of the provider is such that they are known to provide industry-standard protections. Sometimes, scammers pose as OEM part providers and offer low prices. However, they might be selling replicas or substandard parts. The adage "buyer beware" should be taken seriously, particularly if you're procuring several spare parts for your organization. In this video, you explored original equipment manufacturers and the impact they have on the security of computer hardware. You found that OEMs play a vital role in designing, producing, and securing hardware components, implementing firmware security measures, integrating security chips like TPMs, and ensuring compliance with industry-standard security protocols. By keeping aware of OEM alignment with security best practices, you can make more informed choices that will keep your organization safe. Data storage, whether on local drives, removable media, or in the cloud, offers a tempting trove for hackers. Information stored can contain value in many ways, such as company secrets or confidential customer information that can be sold or held for ransom under threat of releasing information to the public, thus damaging the company's reputation. Furthermore, unauthorized access isn't the only threat to be mindful of. A USB stick can also be a vector from which a hacker can install malware on a computer, bypassing cybersecurity checkpoints. Therefore, an IT professional at a company must be safeguarded against both eventualities. In this video, you will explore storage encryption, a security approach that provides a vital layer of defense by transforming data into unreadable ciphertext accessible only with the correct decryption key. You'll learn about how storage encryption works and the different types available, the importance of strong encryption algorithms, tools, and technologies for storage encryption, and best practices for implementing it effectively. Alternatively, one could employ file-level encryption, an approach that is not as encompassing as a full drive encryption, but instead focuses on a file-level basis. Retaining the focus of encryption at the file level gives granular control. It might not present the same level of security as a full drive encryption. However, this level of protection may not always be required and can slow down processes. File-level encryption can coexist with other security measures, such as access controls and data loss prevention policies. This would be an example of defense in depth as you present many obstacles to a would-be hacker. Strong encryption algorithms are enforced when the data being stored is sensitive. Banking information or medical information will require such an approach. The complexity of decrypting data without the corresponding encryption key is high, so the presence of it is a deterrent to unauthorized access and data breaches. When considering key generation for encryption, two primary types are asymmetric and symmetric encryption. Before distinguishing between the two, let's dig deeper into how encryption works at a general level. Encryption can be achieved by converting data into a code only authorized people can read. This concept is called encrypting the data. Perhaps the most famous version was the Enigma machine, which was cracked by the Allies in World War II, allowing them insight into German military movements. Encryption is crucial in protecting sensitive information from malicious actors' access. The practice of encrypting data that is stored on your hard drive is part of a defense in-depth practice. This is to further deter hackers. Different types of storage encryption techniques can be employed to secure data. Full disk encryption, or FDE, is the data protection mechanism that encrypts all contents on a storage device at the sector level. When one is employing an FDE approach, then the encryption will encompass the operating system, installed applications, and all user-generated data. The state-of-the-art in this regard is the Advanced Encryption Standard, or AES, which requires a decryption key to access any portion of the encrypted disk. This renders the data unreadable without the correct key, providing strong protection against unauthorized access in the event of device loss or theft. FDE often integrates with the system's boot process, requiring key-based authentication before the operating system loads. Asymmetric encryption, also known as public key cryptography, is the practice of using two keys. The two keys involved are called the public key and the private key. The encryption is written so that it is possible to have a known public key, which can be distributed and known by all. The private key, however, is kept secret and used for decryption. This method enables secure communication between parties without needing to exchange secret keys beforehand, making it suitable for secure email communication and digital signatures. This approach is in contrast to symmetric encryption, which employs a single key for both encryption and decryption processes. As the same key is used for encrypting and decrypting, this key must be kept confidential and only shared with the trusted parties involved in the exchange. While symmetric encryption is typically faster and more efficient than asymmetric encryption, securely sharing the key presents a challenge, especially in large-scale deployments. Now, let's talk about the tools and technologies available for implementing encryption. BitLocker is a powerful encryption tool available in Windows operating systems designed to secure data stored on drives effectively. With BitLocker, users can encrypt all parts of their drive, including the operating system, applications, and user-generated data. This robust encryption mechanism ensures that data remains protected against unauthorized access even if the drive is lost or stolen. In addition to encrypting data, BitLocker offers features for securely managing encryption keys. Users can store encryption keys locally on the system, on a USB drive, or in Active Directory for centralized management. This flexibility enables organizations to implement secure key management practices tailored to their needs. Implementing and managing storage encryption effectively requires following best practices. This includes regularly updating encryption algorithms to ensure they remain secure against evolving threats. It is also important to periodically back up encryption keys and store them securely to prevent data loss in case of key loss. In this video, you were made aware of the potential dangers of using a USB stick. This includes its use both as a vector for attack or as a means of extracting confidential company data. You learned how encryption works and how it can be incorporated into a layered approach to defend the integrity of a company. You also explored the different types of encryption, BitLocker as a tool for securing data, and best practices for implementing encryption in your organization. You are now more knowledgeable about yet another defense strategy for keeping your data secure, even if it falls into the wrong hands. When one thinks of securing a computer, the first images that spring to mind are antivirus and firewalls. These are important aspects of safeguarding company intellectual property, though a more fundamental consideration is protecting the devices that host company information and applications. Preventing unauthorized access starts with ensuring that a device's physical security is maintained. This video aims to provide a comprehensive overview of the basic principles of physical security as they apply to IT devices. You will learn about relevant threats, vulnerabilities, and methods for safeguarding your hardware through various physical security measures such as locks, access control systems, and surveillance. Much thought is placed into creating safe sites for housing company devices. Considerations are made to safeguard against threats such as theft, vandalism, and unauthorized access, which pose significant risks to IT devices and data. Vulnerabilities in physical security can arise from weak access controls, lack of surveillance, or inadequate security measures. While a cyber hacker will attempt to access company data by circumventing digital safeguards, A thief might achieve the same by stealing a hard drive containing sensitive data or damaging company property to disrupt daily operations. Other dangers that a company needs to consider may not be malicious, but they can equally harm a company's productivity. They include natural dangers such as earthquakes, flooding, or lightning surges, and other mundane dangers such as overloading plug sockets or spilled drinks. Now that you know about the physical dangers that may threaten devices, let's get familiar with the measures for safeguarding against them. A simple yet effective step to safeguard computers is the application of locks to secure physical access points such as doors, windows, and entryways to prevent intruders from accessing IT devices. Many organizations implement physical constraints in accessing where devices are stored. This is achieved by segmenting the workforce and providing access to employees only necessary to their work area. Using a key card to access various parts of the building helps ensure that only the appropriate personnel are allowed physical access. Additionally, one can place a digital lock on the computer itself. Thus, when a legitimate system user leaves their station, the computer is not vulnerable to tampering. Digital locks can be subject to company policy and must balance usability and safety. Typically, this is done through the application of a timeout phase, which the user can configure to their own tastes. Often, timeouts will have a grace period where any activity on the computer peripherals should bring it back to life without re-authenticating. This grace, however, will be subject to company policy, as an excess lag in automatic logging will compromise safety standards. To reiterate the importance of physical security, note that gaining physical access to a device can allow a malicious actor to compromise security through a number of methods. If the device is active and authenticated, then software can be installed to provide remote access. Alternatively, hardware components can be used to circumvent security measures. These might include keyloggers or backdoor entries that can be later accessed. Firmware modifications involve altering the BIOS or basic input-output system, derailing inbuilt security checks, and ensuring a device operates in a safe environment. The goal of a malicious actor may not be to gain entry to the system, but instead disrupt operations by damaging company property. This could be done with the intent of vandalism or to interrupt a company's daily operations purposely. Thus, a secure environment is essential to prevent unauthorized individuals from gaining access to company facilities. You learned that locks can be both physical and digital and create spaces that only authenticated individuals can enter. But what other safeguards are available? One approach taken from military procedures is physical access control. Access to the building is restricted to the lobby. Guests can enter here and await further clearances. Employees will have means of accessing their own area of work. Additional areas that may contain more sensitive equipment, such as servers, are further restricted to access from authenticated users. This can be done with electronic locks that will respond to a user's key card. This practice, which mirrors digital segmentation, places obstacles in accessing parts of the company that one is not authorized to be in. Further measures include the use of surveillance cameras that will record the movement of people. In this video, you were introduced to the importance of physical security for safeguarding digital devices. Common threats are theft, vandalism, and unauthorized access, while vulnerabilities include weak access controls, lack of surveillance, and inadequate security measures. Fortunately, there are measures for safeguarding against these, such as locking access points, physical access control, and surveillance cameras. Awareness of these principles of security strategy will empower an IT professional to create environments that are secure from intentional and unintentional harm. A warehouse typically has many products being delivered and collected at any time during the working day. Organization of so many moving parts can pose a huge coordination challenge. Consider a crate of goods arriving at a warehouse and being placed in a location other than its intended destination. That crate will be delayed before shipping or might be forgotten altogether. How did warehouse managers address this issue? By the end of this video, you will understand how radio frequency identification, or RFID tags, emerged to tackle this issue. You'll also find out how their use has expanded to include activities such as tracking people and goods and making contactless payments. In addition, you will know that this technology's versatility means that it can also be applied to maintaining physical access control, determining in a configurable way which doors an employee can access and which ones should remain closed. RFID is a radio-based technology that originated as a means of tracking goods, but has grown to be a useful tool prevalent in many industries. Soon you will have a far greater understanding of the technology, its uses, and some considerations on the best practices to its safe application. RFID technology uses radio waves to identify and track objects with RFID tags. These tags contain electronically stored information that RFID readers can read. Operating on radio frequency, RFID technology is comprised of two parts, the RFID tag and the RFID reader. The tag emits a signal that the reader can track. The signal can indicate location, but can also contain information relating to the tag. An RFID tag can either be active or passive. An active tag will perform tasks like sending out tracking information and requires a battery. A passive tag does not require a battery. The tag instead uses an electromagnetic coupling to draw sufficient power from the reader to transmit a message. RFID technology plays a crucial role in physical security systems by providing a secure and efficient way to control access. RFID tags can be attached to employee badges or assets, allowing authorized personnel to gain entry to secure areas. Organizations can ensure that only authorized individuals can access restricted areas by implementing RFID readers at entry points. As an employee's role changes, the area that they are permitted to access may also change. Through the use of RFID tags, companies can update an employee's authorization levels from a centralized source which gets updated on the readers. In addition to a flexible access approach, it can also be configured to log the activities. This means that a record of movement can be retained, enhancing overall security. One of the key benefits of RFID technology is its ability to enhance overall physical security. Organizations can enforce access control measures and prevent unauthorized entry by using RFID tags and readers. Additionally, RFID technology enables real-time tracking of assets, reducing the risk of theft or loss. They are very robust and offer accurate readings. They have a versatile application which makes them useful for many industries. They are inexpensive and do not require a line of sight. This means that the tag can be present on a car or on person, and the information can be read without having to present a card to a scanner. Due to its versatility, RFID technology has a wide range of applications in various industries. In corporate security, RFID technology can monitor employee access to different workplace areas. The employee's card will contain information about the areas authorized for access. The RFID will only trigger a door to open if the appropriate clearances have been granted. Additionally, companies can use this technology to monitor devices. An embedded RFID tag can be used to monitor the location of company property at all times. This same functionality is applicable in inventory management, as RFID tags can track the movement of products throughout the supply chain, improving efficiency and reducing errors. This can ensure that items that arrive at a warehouse will not get lost and can be shipped promptly. Additionally, it can be applied to quality control. Consider a scenario where food items have been recalled. They may have contaminated other items in transit, so how are they monitored? Through the use of RFID technology, it is now possible to track the contaminated item and identify where cross-contamination may have occurred with other items and recall only these food items. Finally, RFID is used in some passports to transmit information on the passenger and in credit cards for contactless payment. Organizations should consider several best practices to ensure effectiveness when implementing an RFID-based security system. The versatility of RFID cards means that they have a wide range of uses, from credit card payments to contactless toll payments. This means that high levels of encryption must be used to ensure that the information is not cloned or otherwise sent by a fake RFID tag. This requires properly configuring RFID readers, securing communication channels, and regularly updating software to prevent vulnerabilities. In this video, you discovered how RFID technology offers a valuable solution for enhancing physical security and access control systems. By leveraging RFID tags and readers, organizations can improve security measures, control access to secure areas, and track assets effectively. Implementing RFID technology in security systems can address vital needs in today's tech-driven landscape, providing a reliable and efficient solution for safeguarding physical environments. You've completed the second week of this course, and by doing so, you've increased your knowledge of how to improve system and network security at the hardware level. Before you continue, let's recap the core topics that you were introduced to. Before the module quiz, this would also be an ideal opportunity to revisit the previous content and make sure that you're fully prepared. You began this week with an overview of the basic input-output system or BIOS and came to better understand what it is, the role that it plays in hardware interactions, and its significance in hardware security. You learned that the primary function of the BIOS is to initialize hardware components, load the operating system to the RAM, and ensure that a computer boots safely. However, as technology has changed over time, this has created demands BIOS can't always satisfy in a secure way. This paved the way for the Unified Extensible Firmware Interface, or UEFI, an evolution of BIOS that improves both performance and security. You found that UEFI offers better compatibility with the advanced architecture of modern computer systems, and it features Secure Boot, a technology that uses cryptography to create unique keys for boot-up processes. Together, these functionalities ensure more seamless integration and reduced risk of unauthorized access during boot-up. You were guided through the steps for configuring UEFI and discovered how to adjust settings for the boot order, verify digital signatures with Secure Boot, and safeguard your configuration using admin setup lockout and master password lockout. You also became aware of some advanced security features, namely the Trusted Platform Module or TPM, a hardware chip for storing cryptographic keys, and Secure Attention Mode or SAM, a security mechanism that prevents malicious code from manipulating firmware. You then became familiar with malware and vulnerabilities that affect UEFI. Malware includes rootkits that create entry points for unauthorized access, bootkits that take control of the boot process, and code that modifies UEFI firmware. As for vulnerabilities, a complex code base, outdated firmware, and insecure configuration can all make UEFI more susceptible to attack. Fortunately, this can be mitigated by updating the firmware regularly, configuring Secure Boot, and conducting periodic UEFI security audits. Next, you moved on to hardware security. This started with hardware firewalls, which are devices that provide protection by filtering incoming and outgoing traffic. You explored key functionalities such as packet filtering, stateful inspection, and demilitarized zones. You also learned about the advantages of hardware firewalls over their software counterparts, like their ability to protect a network rather than a single device, cost efficiency, and better security due to running on a separate operating system. You then became familiar with original equipment manufacturers or OEMs, the companies that design and build computer components. Because OEMs may adhere to different standards for security and testing, you found that it is important to choose partners carefully to ensure that you acquire components that meet your protection needs. You also learned about storage encryption, which is the practice of transforming data on storage devices into unreadable text that can only be deciphered with a decryption key. This method ensures that even if someone gets a hold of a hard drive or USB stick containing sensitive information, it will be inaccessible to them. You distinguished between the all-encompassing full disk encryption and the more granular file-level approach, and you became aware of asymmetric encryption, which requires a public key and private key, versus symmetric encryption, which relies on one key for encryption and decryption. Following this, you moved on to the concept of physical security for IT devices. While you've learned quite a bit about secure configurations, it's equally important to restrict who can even engage with devices. Physical threats include theft, vandalism, and unauthorized access, while vulnerabilities to be mindful of include a lack of access controls, surveillance, and security measures. You found that some best practices for dealing with these are to lock access points, implement physical constraints, and monitor with cameras. You discovered that a now commonplace practice that introduces security complications is bring your own device, or BYOD, the idea of employees accessing company networks using their personal devices. Because these devices are not secured in the same way that company-issued devices are, organizations must rely on other means, such as stricter authentication methods and establishing clear policies on BYOD usage. Any measures should be implemented thoughtfully to ensure a balance of security and productivity. Finally, you became familiar with radio frequency identification, or RFID, a technology that uses radio waves to identify and track objects with tags. While originally intended for keeping track of goods in transit, it found additional purpose as a tool for physical access control. RFID tags containing access permissions can be added to employee badges, while RFID readers at locked entry points will allow or deny access depending on the permissions given. Great work getting through this week and expanding your understanding of hardware security. By getting here, you've moved a little further toward your goal of becoming an IT professional. Within the sophisticated framework of our current digital landscape, data storage stands as a crucial cornerstone vital for the encoding, preservation, and retrieval of digital information. As we explore the spectrum of storage mediums, it becomes apparent how deeply the evolution of these technologies is connected with our escalating digital requirements. In this video, you will become familiar with how digital data is stored, accessed, and managed. This includes physical formats and newer approaches that require connectivity. You'll go over important factors to consider when choosing the solution that best fits your needs and emerge with a strong understanding of data storage fundamentals. The digital era is built on the foundation of data storage, a critical technology enabling the encoding, preservation, and retrieval of information. As we explore the characteristics of various storage mediums, it's clear that the evolution of these technologies mirrors the changing landscapes of our digital demands. Let's discuss the storage options that are currently available, starting with the more traditional physical solutions. Hard disk drives, or HDDs, have been the mainstay of data storage for decades, utilizing magnetic recording on spinning platters to store vast amounts of data. Known for their cost effectiveness, HDDs are ideal for extensive storage requirements. However, their reliance on mechanical parts makes them susceptible to wear and potentially slower access speeds, especially when compared to more modern solutions. Solid-state drives, or SSDs, represent a leap forward in storage technology, eliminating moving parts by storing data on flash memory chips. This not only results in faster data access times and improved durability, but also leads to lower power consumption. The downside is the higher cost per gigabyte of storage, a factor that is steadily becoming less significant as SSD technology advances and becomes more affordable. Optical discs, including CDs, DVDs, and Blu-ray discs, offer a removable form of data storage that has been widely used for both personal and professional purposes. They rely on lasers to read and write data, providing a cost-effective way to distribute software, music, movies, and more. Although their popularity has waned with the rise of streaming services and USB storage devices, optical discs still serve as a viable backup solution for many. Magnetic tape storage, one of the oldest forms of digital data storage still in use, offers high capacity and reliability at a low cost per gigabyte, making it an excellent choice for archival storage. Tapes are especially favored in enterprise settings for backup and disaster recovery purposes. Despite their slower access times compared to disk-based storage, magnetic tapes' longevity and cost-effectiveness keep them relevant in scenarios where access speed is not a priority. Now that you know about traditional methods for storing data, let's learn about the modern solutions that continue to gain popularity. The rise of cloud storage has transformed how we think about data management, providing scalable, remote storage solutions accessible from any internet-connected device. This model offers unparalleled convenience and flexibility, though it necessitates careful consideration of security and cost implications. For those seeking a middle ground between the physical control of hardware and the accessibility of cloud storage, Network-Attached Storage, or NAS, offers a compelling option. NAS systems connect directly to a network, enabling file sharing and storage centralization in a way that's both efficient and scalable, particularly suited for business environments. Choosing the optimal storage solution involves a nuanced understanding of various critical factors, each playing a significant role in how data is stored, accessed, and preserved. This decision-making process is not just technical but strategic, affecting long-term data management and operational efficiency. Important factors are capacity, speed, reliability, and cost. Let's explore each of these aspects in greater depth. Determining the right capacity involves not just assessing current data storage needs, but also forecasting future growth. With digital data expanding at an exponential rate, it's essential to choose a solution that can scale accordingly. This foresight prevents the need for frequent upgrades and migrations, ensuring a smoother continuity of operations. The speed at which data can be accessed and transferred directly impacts productivity and user experience. For applications where real-time data processing is vital, such as financial transactions or online gaming, selecting high-speed storage solutions like SSDs or high-performance cloud services is paramount. Balancing speed with cost considerations is key to finding a solution that meets operational demands without overspending. Data is an invaluable asset, making its integrity and security paramount. Reliability encompasses not only the physical durability of storage media, but also the resilience of data against corruption, unauthorized access, and loss. High-reliability storage solutions offer robust backup and recovery systems, ensuring that data remains intact and retrievable under various circumstances. The financial aspect of choosing a storage solution involves more than the initial purchase or subscription fee. It encompasses the total cost of ownership, including maintenance, energy consumption for physical storage, and potential scalability costs. For businesses, aligning storage costs with budgetary constraints while ensuring efficiency and reliability is a critical balance to achieve. In this video, you were introduced to various methods for storing digital data, ranging from traditional formats to more flexible internet-based approaches. You also learned about factors to consider when choosing a suitable solution for you or your organization. As we stand at the convergence of technological advancement and increasing data demands, the importance of choosing the right data storage solution has never been more critical. From the venerable magnetic tape to the cutting-edge cloud storage, each option presents its own sets of advantages, challenges, and considerations. Balancing capacity, speed, reliability, and cost against the backdrop of future growth and technological shifts is essential for ensuring that our data not only remains secure, but also accessible and manageable in an ever-evolving digital world. For business use, a limitation of physical storage formats is the difficulty of sharing the data across the organization. Fortunately, modern solutions can leverage the internet to overcome such barriers, and one that has gained popularity is Network-Attached Storage, commonly referred to as NAS. In this video, you will enhance your understanding of how NAS systems operate, their advantages, and some typical use cases. You'll also learn about key considerations when setting up a NAS and the role it plays in simplifying data access and sharing across networks. NAS provides centralized, scalable data storage accessible over a network. Designed for ease of use, NAS systems feature web-based management for remote configuration, making them suitable for both personal and business applications. With scalable storage, enhanced data security, and cost efficiency, NAS is an essential solution for modern data management needs. NAS systems are standalone appliances connected to a network. They come equipped with their own operating system and are configured via a web-based interface. NAS units vary in size, from units as small as a home router to large rack-mounted systems offering storage capacity that can scale from a few terabytes to several petabytes. Let's explore some of the key operational features of NAS systems. NAS systems function independently within a network environment. Unlike direct attached storage or DAS, which requires a direct connection to a computer, NAS devices can serve multiple clients over a network simultaneously. Each NAS comes with a built-in operating system or OS optimized for file storage and sharing. This OS facilitates the management of data storage, security, and network connectivity, providing a user-friendly interface for system administrators. Configuration and management of NAS units are predominantly done through web-based interfaces. This allows for remote administration, enabling users to adjust settings, manage storage capacities, and configure access permissions from any location within the network. NAS devices are also designed to accommodate growing data storage needs. This scalability makes NAS an ideal solution for individual and business users with varying data storage requirements. For business use, NAS systems carry several advantages over other data storage methods. For one, NAS systems simplify data access and sharing across a network, making it ideal for collaborative environments. You can also easily add more storage as needed without disrupting existing network infrastructure. A NAS system reduces the need for individual hard drives on every workstation, lowering overall IT costs. And features like RAID configurations and automatic backups enhance data security and integrity. Next, let's get familiar with some typical use cases for NAS for both home users and businesses. Home users may find NAS useful for storing and streaming multimedia content to various devices such as smart TVs, smartphones, and tablets. They can also easily share documents, photos, and videos within a household. And they can centralize backups for all family devices, ensuring data is safe and retrievable. Businesses will find that NAS makes it simple to share files and collaborate on documents across departments or locations in real time. NAS also serves as storage for virtual machines, offering flexibility and efficiency in resource management. And finally, it is an ideal solution for storing large volumes of video surveillance data, allowing for easy access and review. When setting up a NAS system, several key considerations must be addressed to ensure the system operates efficiently and securely. These considerations are crucial for both initial setup and long-term operation. First of all, proper network setup is vital for optimal NAS performance and accessibility. This involves ensuring that the NAS device is correctly connected to the network and configured to be accessible by the intended devices and users. It includes setting up IP addresses, network shares, and possibly VLANs to segregate NAS traffic from regular network traffic if needed for performance or security reasons. The goal is to ensure smooth data flow between the NAS and client devices without bottlenecks or undue access latency. Data security is another critical aspect, requiring the implementation of encryption, user access controls, and secure backup solutions. Encryption protects data at rest and in transit, making it unreadable to unauthorized individuals. User access controls are necessary to define who can access what data on the NAS, effectively preventing unauthorized access to sensitive information. Implementing strong access control measures, possibly including multi-factor authentication, ensures that only authorized users can access the NAS. Additionally, secure backup solutions are vital to protect against data loss due to hardware failure, software issues, or cyber threats, ensuring data integrity and availability. Finally, scalability must be considered to ensure the NAS solution can accommodate future data growth. This involves selecting a NAS system that can be expanded with additional storage capacity as needed, or ensuring the system can work in a clustered environment for additional scalability. As data storage needs increase, planning for scalability from the outset can save significant time and resources later on. In this video, you learned that network-attached storage offers an efficient, scalable, and secure solution for managing data across networks. Suitable for both personal and business use, NAS systems facilitate easy data access, sharing, and storage through their web-based management and scalable capacities. They address the growing data needs with ease, making them indispensable in modern IT infrastructures for their cost-effectiveness and robust data protection features. Understanding disk partitioning and file systems is essential for managing data effectively in any computing environment. These fundamental concepts play a crucial role in how data is organized, accessed, and stored on storage devices such as hard drives, solid-state drives or SSD, and external storage mediums. This video deals with disk partitioning and file systems, their significance in data organization and access, and their impact on data security, performance, and compatibility. Let's start by defining disk partitioning. Disk partitioning is the process of dividing a disk into separate sections, each functioning as a distinct storage unit known as a partition. This practice allows for more efficient data management, as each partition can be used for different purposes. For instance, one partition may contain the operating system, another for personal data, and a third for backup. This separation not only simplifies data organization, but also enhances the security and performance of the system. There are two different methods to partition a disk. One must choose between using the master boot record, also known as MBR, or the GUID partition table, or GPT for short, as the partition table. The MBR is an older standard that supports disks up to 2 TB in size and allows up to 4 primary partitions. In contrast, GPT is a newer standard that supports disks larger than 2 TB and allows for virtually unlimited primary partitions. GPT is also more resilient to data corruption and includes redundancy by storing multiple copies of the partition table across the disk. This distinction between MBR and GPT is crucial for systems that need to handle large volumes of data or require a higher level of data integrity. Let's move on to file systems. A file system is the method and data structure that determines how an operating system stores and retrieves data. Without a file system, stored information would be one large body of data with no way to tell where one piece of data stops and the next begins. The file system keeps track of all the files on the disk, including their physical location on the drive, their size, and their attributes like permissions and timestamps. Common file systems include NTFS or New Technology File System, FAT32 or File Allocation Table 32, and exFAT or Extended File Allocation Table. Selecting the right file system is a critical decision that affects data security, system performance, and compatibility. Each has its unique characteristics, advantages, and limitations. Let's explore each in more detail. Windows operating systems use NTFS. It supports large files and drives, file permissions for security, and shadow copies for backups. It is the preferred file system for Windows environments due to its robust features and compatibility. On the other hand, FAT32 is an older file system compatible with a wide range of devices and operating systems. However, it has limitations such as a maximum file size of 4 GB and a maximum partition size of 8 TB, which make it less suitable for modern applications that require the storage of large files. Lastly, exFAT is a lightweight file system like FAT32, but without the latter's limitations. exFAT supports larger files and partitions and is commonly used for USB flash drives and external hard drives to ensure compatibility across different devices and operating systems. So far, you've learned that disk partitioning and the choice of file system have significant implications for data organization and access. They influence how data is stored, the speed of data retrieval, and the compatibility between different devices and operating systems. However, these concepts also play a vital role in data security. For instance, NTFS file permissions can restrict access to sensitive data. It supports the encrypting file system or EFS, allowing the encryption of individual files and folders. Partitioning a disk can also have performance implications. By segregating the operating system and applications from user data, the system can run more efficiently. In the event of a system failure, having user data on a separate partition can simplify the recovery process, as the system partition can be restored or reinstalled without affecting user data. The organization and management of data through disk partitioning and file systems are crucial components of modern computing. They not only facilitate the efficient storage and retrieval of data, but also enhance system security and performance. Understanding these concepts enables you to make informed decisions about how to organize data best and optimize computing environments for both efficiency and security. Chances are that, like most people, you constantly run out of storage space, whether on your mobile device, laptop, or even in the cloud. With the exponential growth of digital data in modern life, the need for larger storage capacities has become inevitable. From high-definition videos to complex datasets, the demand for storage is ever increasing. This is where data compression techniques step in as lifesavers, revolutionizing how you manage, store, and transmit digital information. This video will introduce you to different data compression methods, including lossless and lossy techniques and their appropriate applications. This knowledge will help you choose better data compression and transmission methods. Let's get started. Data compression is a technique for minimizing the size of data files, enabling more efficient storage and faster transmission. This method is crucial across various industries and applications, from the internet to multimedia production, enhancing the efficiency of data management and communication. Let's discuss the two methods for data compression. First, lossless data compression allows for the original data to be perfectly reconstructed from the compressed data. This method is essential for applications where the exact reproduction of the original data is critical, such as text documents, software applications, and certain types of media files. Lossless compression works by eliminating redundancy without sacrificing any information. Common algorithms and techniques used in lossless compression include run-length encoding or RLE. This technique compresses data by replacing sequences of repeated characters with a single character and a count of its repetitions. It is particularly effective for data with many consecutive repeated characters. Huffman coding is another popular lossless method that assigns shorter codes to more frequent characters and longer codes to less frequent ones. Huffman coding is widely used due to its simplicity and effectiveness. And Lempel-Ziv-Welch or LZW is an algorithm that builds a dictionary of sequences encountered in the data, replacing these sequences with shorter references to the dictionary. LZW is the basis for many file compression formats, including GIF and TIFF. Lossless compression is pivotal in scenarios where data integrity is paramount. It is widely used in text compression, software distribution, and archival, ensuring that data can be perfectly recovered after compression. Contrary to lossless compression, lossy techniques allow for some loss of information, trading data fidelity for a higher compression ratio. This approach is suitable for applications where a perfect reproduction of the original data is not necessary, such as in audio, video, and images. By removing parts of the data that are less important to human perception, significant reductions in file size can be achieved. Popular lossy compression techniques include JPEG, which is short for Joint Photographic Experts Group. JPEG is a common format for compressing photographic images. It uses the discrete cosine transform, or DCT, to reduce the file size by discarding less perceptible information. Next is MP3 or MPEG Audio Layer 3, widely used for audio compression. MP3 compresses sound files by removing frequencies that are less audible to human ears, effectively reducing the file size while maintaining acceptable sound quality. Another lossy compression technique is MPEG or Motion Picture Experts Group, a standard for video compression. It achieves high compression ratios by only storing changes between consecutive frames and reducing color resolution, among other techniques. Lossy compression is invaluable in multimedia applications, where it enables the storage and streaming of high-quality audio and video with significantly reduced data sizes. It is the backbone of modern digital media, facilitating the distribution and consumption of multimedia content on the internet and digital broadcasting. Next, let's explore modern data compression techniques. These highly sophisticated techniques often incorporate machine learning algorithms to identify patterns and redundancies in data that can be effectively compressed. There are many tools and software libraries available that implement these algorithms. They offer general-purpose compression solutions such as gzip and bzip2, but also specialized compressors tailored to specific types of data like FLAC for lossless audio compression. The use of data compression techniques is extensively applied throughout digital storage and transmission. In everyday computing, compressed file formats like zip and rar allow users to reduce the size of files for storage and email attachments. Data compression greatly improves the efficiency of the Internet by reducing bandwidth usage and enhancing web page loading times and streaming quality. Moreover, in professional fields such as digital cinema, medical imaging, and scientific data analysis, compression techniques are vital for managing vast amounts of data efficiently. In summary, while lossless compression is essential for preserving data integrity in critical applications, lossy compression plays a key role in the accessibility and enjoyment of multimedia content. The choice between lossless and lossy compression depends on the specific requirements of the application, including the need for data fidelity versus the need for storage efficiency and transmission speed. In this video, you learned that data compression is a fundamental technology that supports the efficient management, storage, and transmission of digital information. By leveraging lossless and lossy compression techniques, users can optimize the balance between data fidelity and storage efficiency. As digital data continues to grow in volume and importance, the role of data compression in enabling the digital world's functionality and efficiency cannot be overstated. Whether in everyday file storage, internet browsing, or professional media production, data compression remains an indispensable tool in the digital toolkit. In the digital age, data is often described as the new oil, driving innovation, decision-making, and competitive advantage in the modern business landscape. But much like crude oil, raw data must be refined to unlock its true value. This is where data processing comes into play, a critical series of steps that transform raw data into meaningful information, enabling businesses and organizations to make informed decisions. This video explores the fundamental processes of data processing and its importance. You will also learn about the ETL process. Let's get started by defining data processing. Data processing involves collecting raw data, transforming it through various stages, and ultimately producing actionable insights or structured information. This process can include steps such as validation, sorting, summarization, aggregation, analysis, and reporting. The aim is to convert raw data into a format that is accessible, reliable, and useful for end users such as business analysts, decision makers, and automated systems. The journey from raw data to meaningful insights involves several key stages. Step 1 is data collection. This involves gathering data from various sources, including sensors, user inputs, and transactional systems. Step 2 is preparing the data. This involves cleaning and structuring data to ensure its quality and usability. The third step is to enter the data into a processing system or software. And step 4 is data processing. This involves applying algorithms and computations to analyze and transform data. Step 5 is generating output in the form of insights, reports, and visualizations that inform decision-making. And finally, the last step is to save the processed data in a way that facilitates easy access and analysis in the future. In the modern data-driven world, data processing is crucial for several reasons. For instance, it offers competitive advantages by enabling faster identification of market trends and optimization of operations. It also enhances decision-making by relying on data rather than intuition. And third, it improves operational efficiency through automation. Moreover, data processing enhances customer experiences by allowing for personalized services and responses. However, challenges such as data privacy, security, and potential biases must be managed with robust governance. With advances in AI, machine learning, and cloud computing, the future of data processing promises efficiency and opportunities for innovation across industries. Now that you have a solid background on the fundamental steps and importance of data processing, let's shift the focus to an industry-renowned process in data handling, the ETL process. Knowing about the ETL is crucial for anyone involved in data management, business intelligence or BI, analytics, and IT in general. ETL stands for extract, transform, and load. Let's briefly expand on what this means. Extraction involves pulling data from its source systems. These sources may include databases, CRM systems, flat files, and more. The next step is to transform the extracted data. This can include cleaning, aggregating, deduplicating, and preparing the data according to the needs of the end user or application. The transformation step ensures data is in the right format and quality for analysis. The final step is loading the transformed data into a target system. This is often a data warehouse, but can also be other types of databases or storage systems. The loading step involves writing the data into the target system, where it can be used for reporting, analysis, or further processing. ETL is not just another process, it's a fundamental framework. For one, it's essential for data integration. ETL is key to combining data from disparate sources into a coherent dataset for comprehensive analysis. By mastering ETL, you can ensure data across an organization is harmonized and actionable. Having a good handle on ETL is also vital for controlling data quality and accuracy. Through the transformation stage of ETL, organizations can clean, validate, and standardize data, improving its quality and reliability for business decisions. Moreover, ETL processes are fundamental to BI and analytics initiatives. They provide the data groundwork needed for insights, trends, and decision support systems that drive business strategies. Learning about ETL includes understanding how to automate the data integration process. This reduces manual errors, saves time, and increases operational efficiency. And then there is the scalability factor. As organizations grow, so does their data. ETL processes are scalable, allowing for the handling of increased data volumes without sacrificing performance. Lastly, knowing ETL processes allows organizations to adapt to new data sources and technologies, ensuring that data management practices are future-proofed against evolving IT landscapes. In this video, you learned that data processing is a foundational aspect of modern computing, playing a crucial role in unlocking the value of data. By transforming raw data into actionable insights, organizations can drive better decision-making, enhance operational efficiency, and secure a competitive advantage in the marketplace. And you now know that organizations use the ETL process to efficiently handle data from multiple sources, ensuring that it is accurate, consistent, and readily available for analysis and decision-making. As organizations continue to generate data at an unprecedented rate, the importance of effective data processing will only grow, highlighting the need for continued innovation and ethical consideration in this critical field. Image and video processing technologies are pivotal in the digital content landscape, empowering creators and engineers to enhance visual media's clarity, efficiency, and overall impact. These technologies improve the aesthetics of digital media and enhance the functionality and accessibility of vast amounts of information communicated through images and videos. This video covers the core aspects of image and video processing. You will cover the fundamental concepts and the significant role of various software tools. Moreover, you will learn about the critical contribution of hardware, particularly GPUs, in executing complex media-related processing tasks. Let's start with image processing. Image processing is the technique of manipulating images to achieve desired effects, improve quality, or extract information. This manipulation ranges from simple tasks like adjusting brightness and contrast to more complex operations such as object detection, image segmentation, and color correction. You're likely familiar with image formats such as JPEG and PNG. Each format serves distinct purposes and is chosen based on a project's specific needs. For instance, JPEG, which stands for Joint Photographic Experts Group, is known for its efficient compression and widespread use. Next is PNG, or Portable Network Graphics, favored for its lossless compression and transparency support. Then there is GIF, graphics interchange format, popular for animations. And finally, WebP offers excellent compression ratios and quality. What about software for image processing? There are diverse tools catering to various needs and expertise levels. For users within the Microsoft ecosystem, especially on Windows 11, tools like Photos and the updated version of Paint offer a range of image editing capabilities. These applications cater to casual users and those with more advanced needs, providing basic photo editing, drawing, and graphic design options. On the development side, libraries such as OpenCV or Open Source Computer Vision Library and PIL or Python Imaging Library provide programmers with the functionality needed to automate image processing tasks. These libraries enable the development of sophisticated applications that can analyze and manipulate images at scale. Video processing builds on image processing principles, applying similar techniques across sequences of frames to enhance videos or extract information. Let's discuss some additional concepts crucial to video quality and file management, such as bitrate, the amount of data processed per second of video, directly influencing file size and quality, and resolution, which determines the detail and clarity of the video image. Similar to image formats, different video formats cater to various needs. First is MP4 or MPEG-4 Part 14, renowned for its balance of quality and compatibility. Second is AVI or Audio-Video Interleave, which stands out for its minimal compression, ensuring high quality at the cost of larger file sizes. And another commonly used video format is MOV, a QuickTime file format developed by Apple. MOV is known for its high quality and compatibility with iOS devices. Moving on, let's discuss video editing and compression software. Software such as Adobe Premiere Pro, Final Cut Pro, and Handbrake are indispensable tools for creators. These tools allow one to craft compelling visual narratives, optimize videos for streaming, and compress files for efficient distribution without significant loss of quality. Next, let's discuss the role of hardware in image and video processing. While software provides the tools necessary for image and video processing, hardware, particularly the graphics processing unit or GPU, plays a fundamental role in executing these tasks efficiently. GPUs are designed to handle parallel processing, making them exceptionally well suited for computationally intensive image and video processing tasks. In image processing, GPUs accelerate operations such as filtering, transformation, and complex algorithmic manipulations. This kind of real-time processing of high-resolution images is a subfield of digital signal processing or DSP. DSP is used in a wide range of areas, including medical imaging, surveillance, and computer vision. For video processing, the benefits of using GPUs are even more pronounced. The encoding and decoding of video streams, crucial for video playback and streaming, are significantly accelerated by GPUs. Furthermore, advanced video editing tasks that involve effects, transitions, and color grading benefit from the parallel processing power of GPUs, reducing rendering times and enhancing the workflow efficiency for video editors. The beginning of machine learning and deep learning has further expanded the role of GPUs in image and video processing. GPUs are at the heart of training complex models for tasks such as automated image enhancement, object detection, and even generating synthetic media content. Their ability to perform a vast number of calculations simultaneously makes them ideal for the heavy computational demands of these advanced algorithms. In conclusion, the fields of image and video processing are central to the creation, distribution, and consumption of digital media, driving forward innovations that enhance the visual quality and accessibility of content. This video covered the fundamental concepts, tools, and hardware that underpin these processes. You learned that the synergy between software and hardware is critical for achieving the desired outcomes in image and video enhancements. As technology continues to evolve, the potential for new and innovative applications of image and video processing is boundless, promising ever more sophisticated and immersive visual experiences. In today's multimedia landscape, audio is a powerful means of communication, weaving narratives and emotions into the fabric of content. However, the journey of sound from its raw form to its seamless integration into digital platforms is a complex and fascinating process. Audio processing enables the production of high-quality audio content across various platforms through capturing, enhancing, and manipulating sound signals. Whether making music, broadcasting content, or interacting with voice recognition systems, audio processing technologies ensure sound is delivered with clarity, reliability, and impact. As multimedia applications continue to evolve, the role of audio processing in shaping the future of digital media remains unquestionably significant. This video discusses audio processing, exploring fundamental concepts such as audio compression, noise reduction, digital representation of sound, and their profound impact on multimedia. Audio processing begins with capturing sound waves, which are analog signals. These sound waves are transformed into digital signals that computers can understand and process. This transformation is achieved through a process called analog to digital conversion, or ADC. The ADC process samples the sound wave at various points in time, quantifying each sample with a digital value. This digital representation is crucial for further processing and manipulation of sound in various applications. One of the fundamental techniques in audio processing is compression. Audio compression reduces the file size of sound recordings without significantly impacting the sound quality. This is particularly important in the age of digital media, where storage and bandwidth are valuable commodities. There are two types of audio compression: lossless and lossy. Lossless compression includes formats such as FLAC, which stands for Free Lossless Audio Codec, and ALAC, or Apple Lossless Audio Codec. It ensures that audio files are compressed without any loss of information, allowing for an exact reconstruction of the original sound. Lossy compression formats include MP3 or MPEG Audio Layer 3 and AAC, which stands for Advanced Audio Coding. These formats achieve more significant file size reduction by discarding certain audio details, which can result in a decrease in sound quality. Noise reduction is another critical aspect of audio processing. It removes unwanted background noise from sound recordings to enhance clarity and quality. Noise reduction involves employing various filtering techniques and algorithms to distinguish and isolate unwanted noise frequencies from those of the desired sound. Noise reduction is essential in various applications, from professional music production to improving the clarity of voice calls and voice recognition systems. At the heart of audio processing is the digital representation of sound. This involves converting the continuous analog audio signals into a digital format, including sampling, quantization, and encoding. Let's briefly explore each of these steps. Sampling refers to capturing the amplitude of the audio signals at discrete intervals. Quantization involves mapping these amplitude values to a finite set of values, while encoding assigns a binary code to these quantized values. This digital representation is what allows for the extensive manipulation and enhancement of sound in the digital domain. There are various audio processing techniques that are crucial in music production. These include equalization, which balances frequencies to ensure each instrument fits well in the mix; reverb, on the other hand, adds spatial depth; and compression maintains consistent volume levels. These methods collectively shape the sonic quality of music, allowing for the artistic vision to be realized with clarity and precision. Next, let's touch on the two important applications of audio processing, starting with broadcasting. In broadcasting, audio processing ensures high-quality sound transmission, which is crucial for live events and news. This precise approach to sound helps maintain audience engagement through clear and consistent audio content. Second, voice recognition technologies benefit greatly from audio processing advancements, particularly noise reduction and echo cancellation. These improvements have expanded voice recognition applications, enhancing system accuracy in various environments. As a result, voice recognition is more responsive and versatile, supporting a wider range of languages and dialects and facilitating more natural interactions with technology. The evolution of technology plays a pivotal role in advancing audio processing techniques. Sophisticated algorithms and powerful computing hardware enable more complex and efficient audio processing, opening new possibilities in sound manipulation. Artificial intelligence and machine learning are at the forefront of this evolution, offering innovative ways to analyze and process audio signals. In conclusion, audio processing is a foundational part of multimedia creation and consumption, enabling the capturing, manipulation, and experiencing of sound. Through techniques like audio compression, noise reduction, and the digital representation of sound, audio processing enhances the quality and clarity of audio in music production, broadcasting, and voice recognition. As technology continues to evolve, the potential for innovative audio processing techniques expands, promising even greater advancements in how we interact with sound in the digital age. The portable document format, better known as PDF, transcends the boundaries of operating systems, devices, and software applications. This integral file format maintains document integrity and ensures seamless information exchange. This video provides insights into the versatility and utility of the portable document format in digital documentation. Developed by Adobe Systems in the early 1990s, PDF was a response to the growing need for a standard format to preserve the layout and content of documents regardless of the platform used to view them. Over the years, its versatility and utility have made it an indispensable file format for individuals and organizations worldwide. One of the most compelling features of PDF is its platform independence. PDF documents appear the same across all devices, whether you are using a Windows PC, a Mac, a smartphone, or a tablet. This consistency eliminates the common issues associated with document exchange, such as altered formatting and lost data, frequently occurring when documents are shared across different word processing software. PDFs ensure that the document's original layout, fonts, images, and graphics are preserved, making it an ideal format for sharing and publishing documents intended for public consumption or long-term archival. Security is a paramount concern in digital communication, and PDFs address this with several built-in features that enhance document security and integrity. Password protection allows document creators to restrict access to PDF documents, ensuring that only authorized users can open, view, or edit them. Moreover, PDFs support digital signatures, a critical feature for legal documents and contracts, as they provide a verifiable way to authenticate the identity of the document's signatories and maintain the document's integrity. This combination of password protection and digital signatures makes PDFs a trustworthy format for secure document exchange and archival. It's possible that you're familiar with the PDF-A format. This subset of the standard PDF is designed specifically for digitally preserving electronic documents. PDF-A differs from PDF by prohibiting features unsuitable for long-term archiving, such as font linking instead of font embedding and encryption. These characteristics make PDF-A an excellent choice for organizations that must store documents for extended periods while ensuring their future accessibility. Moreover, ensuring documents are accessible to all is not just about compliance with regulations, it's also about a commitment to inclusivity and ensuring that information is available to everyone. PDF allows you to make documents accessible to people with disabilities, in line with the guidelines for accessible document design. These features include text-to-speech compatibility, which allows visually impaired users to listen to the content of a PDF. PDF also enables users to navigate a document using assistive technologies. But what about creating and editing PDFs? Chances are that you've been in a position where you needed to alter something on a PDF. There is a wide range of tools available today, making the creation and editing of PDFs accessible for more people for both personal and professional purposes. From free PDF readers and editors to professional software suites offering advanced features, the ecosystem of PDF tools has evolved to meet diverse needs. Users can convert documents from various formats to PDF, edit PDF content, merge multiple PDFs into one document, or split a single PDF into multiple documents. Additionally, forms can be created directly within a PDF, allowing for the collection of data in a structured and efficient manner. PDF management also includes capabilities for commenting and collaboration, making it easier for teams to review documents, provide feedback, and track revisions without the need for printing or exchanging multiple document versions. Annotations, comments, and highlights can be added directly to a PDF, facilitating a streamlined review process that is both environmentally friendly and cost-effective. Furthermore, advanced PDF editors include functionalities such as batch processing, optical character recognition or OCR, and multimedia integration. In this video, you learned that the Portable Document Format or PDF stands as a testament to the foresight of its creators. It embodies the principles of versatility, security, and utility in digital documentation. Its ability to maintain document integrity across different platforms, coupled with robust security features, makes it an invaluable resource for secure, reliable document exchange and archival. As digital documentation continues to evolve, the PDF remains a fundamental tool, bridging the gap between the analog and digital worlds, ensuring that documents are accessible, secure, and preserved for future generations. Whether for personal use, professional communication, or legal documentation, PDFs offer a comprehensive solution that meets the demands of our increasingly digital society. In an era where digital data has become the backbone of personal and professional lives, safeguarding this information against loss, corruption, or malicious threats is not just advisable, it's imperative. This video delves into the basics of data backup, underscoring its significance and outlining the foundational principles that ensure the security and integrity of digital assets. Data backup is the process of copying and archiving computer data to restore it in the event of data loss. This loss can stem from various scenarios: hardware malfunctions, accidental deletions, software corruption, and increasingly cyber attacks such as ransomware. In such contexts, the absence of a reliable backup can result in irrevocable damage, ranging from the loss of critical personal memories to significant financial and operational setbacks for businesses. So why are backups non-negotiable? Let's discuss a few reasons. First is hardware failure. Hardware is not infallible. Hard drives have a finite lifespan and are susceptible to failures that can lead to data loss. Regular backups ensure that data can be recovered, minimizing disruptions. And then there is human error. One of the most common causes of data loss is accidental deletion or modification by a user. Backups serve as a safety net, allowing data recovery in its original state. Next is cyber threats. The rise of cyber threats, particularly ransomware, poses a significant risk to data integrity. Ransomware encrypts a victim's files, demanding payment for their release. However, with current backups, the leverage of these attacks diminishes substantially as data can be restored without capitulating to ransom demands. Software corruption and system failures serve as additional motivations for creating backups. Beyond the tangible risks posed by hardware malfunctions and human missteps, software itself can be a data threat. Lastly, updates gone awry can corrupt files or render entire datasets inaccessible. Regular backups serve as a critical line of defense, ensuring that you can restore data from a point before the corruption occurred. Understanding the basic principles of data backup is crucial for effective data management and recovery strategies. Here are some of the foundational concepts. A golden rule in the realm of data backup is the 3-2-1 strategy. This approach advises having the following: 3 copies of your data, 1 primary copy and 2 backups, 2 different media types such as hard drives and cloud storage to avoid reliance on one form of storage, and 1 off-site copy to protect against physical disasters like fires or floods that could destroy all local copies. Following this rule will maximize data availability and minimize risks associated with data loss. Another basic principle is the frequency of conducting backups. The value of the data and how often it changes determine the required backup frequency. Daily or even more frequent backups may be necessary for critical data that changes frequently. For less critical or static data, less frequent backups might suffice. Implementing automated backups can ensure consistency and reduce the likelihood of human error. It's crucial to distinguish between backups and storage. While they both involve saving data, their purposes differ. Storage is about keeping data accessible for ongoing use, whereas backups are specifically for recovery if the original data is lost or corrupted. Confusing the two can lead to a false sense of security regarding data recoverability. When choosing a backup solution, several factors should be considered, including the sensitivity and volume of the data, the desired frequency of backups, and the budget. Options range from external hard drives and NAS or network-attached storage devices for local backups to cloud-based services for off-site storage. Each has advantages and considerations such as security, cost, and accessibility. Having a backup strategy is only part of the equation. Moreover, regularly testing backups to ensure that you can restore data successfully is vital. This practice helps identify any issues in the backup process and ensures that data recovery will be smooth and efficient in the event of an actual need. In conclusion, data backup is a critical component of digital asset management, offering a safeguard against a myriad of risks that threaten data integrity and availability. Individuals and organizations can protect themselves against significant losses by understanding and implementing fundamental backup principles. In the digital age, being prepared with a robust backup strategy is not just a best practice, it's necessary for anyone who values their data. Effective data management is one of the core concerns of IT professionals. It is paramount to be knowledgeable about safeguarding data against loss or corruption. One critical technology at the forefront of enhancing data integrity and availability is RAID, Redundant Array of Independent Disks. This technology is pivotal in constructing robust data redundancy and backup strategies, offering a blend of performance, storage efficiency, and data protection. This video explores the fundamentals of RAID, its significance in data redundancy, and its role in comprehensive backup strategies. What is RAID? RAID is a method of storing the same data in different places on multiple hard disks to protect data in the case of a drive failure. By combining multiple physical disks into a single logical unit, RAID spreads data across the disks in various ways, referred to as RAID levels, each offering a different balance of protection, performance, and capacity. Understanding the different RAID levels is essential to appreciate how RAID technology can be tailored to meet specific data storage and protection needs. Let's discuss RAID levels in more detail, starting with RAID 0 or striping. This level splits data evenly across two or more disks with no redundancy, offering improved performance but no fault tolerance. If one disk fails, all data on the array is lost. Next is RAID 1, mirroring. RAID 1 duplicates the same data on two or more disks. It offers excellent data protection since data can be recovered from the other disk if one fails, but it reduces the available storage capacity by half. Then there is RAID 5 striped with parity. RAID 5 distributes parity information, which can be used to reconstruct data in case of a disk failure, along with the data across three or more disks. It provides a balance between performance, storage capacity, and data redundancy. Lastly, RAID 10 is a combination of RAID 1 and RAID 0. This level combines the mirroring of RAID 1 with the striping of RAID 0, offering both high performance and data redundancy. It requires a minimum of 4 disks and offers excellent fault tolerance. Now that you know what RAID is, let's discuss its significance in data redundancy and backup. RAID offers a first line of defense against data loss due to hardware failures. Depending on the RAID level, it ensures the continued operation of a system even when one or more disks fail. RAID ensures that data remains accessible, maintaining business continuity and minimizing downtime. However, it's crucial to understand that RAID is not a substitute for a comprehensive backup strategy. While RAID can protect against hardware failure, it does not guard against data corruption, accidental deletions, or site-wide disasters. Therefore, implementing RAID should be part of a broader data protection plan that includes regular backups stored off-site and possibly in the cloud. Next, let's talk about some common misconceptions about RAID. One common misconception is that RAID can replace traditional backups. However, as previously mentioned, RAID does not protect against all forms of data loss. Another misunderstanding is that all RAID levels provide redundancy. As illustrated with RAID 0, not all levels offer data protection in the event of disk failure. Understanding the specifics of each RAID level is essential for deploying the right RAID setup for your needs. When setting up a RAID system, you need to take several practical considerations into account. First is hardware requirements. Depending on the RAID level, you may need a specific number of disks and possibly a RAID controller card to manage the RAID array. Following configuration best practices is also crucial for maximizing the benefits of RAID. This includes selecting the appropriate RAID level based on the desired balance of performance, redundancy, and storage capacity. You should also ensure all disks are reliable and of similar size. Finally, a RAID system requires monitoring and maintenance. Regular monitoring of RAID arrays is essential for early detection of disk failures. Prompt replacement of faulty disks is critical to maintain the integrity of the RAID setup and protect against data loss. RAID technology is a cornerstone of modern data management strategies, offering enhanced data protection through redundancy. While invaluable for mitigating the risks associated with hardware failures, RAID should be complemented with comprehensive backup solutions to protect against a wider array of data loss scenarios. By understanding the different RAID levels and customizing them to meet an organization's specific data and protection needs, IT professionals can ensure data availability and integrity in the face of various challenges. A reliable backup strategy is essential for the smooth operation of any organization. To develop the most practical and suitable backup strategy, IT professionals require comprehensive knowledge of the two primary options, cloud-based or traditional local backup systems. Factors such as data size, budget constraints, access, and security needs will determine which option is the best fit for an organization. In many cases, a hybrid of cloud and local backups is the most suitable option. This video will discuss the benefits and drawbacks of cloud and local backup systems. Let's start with the advantages of cloud backup. First, cloud-based backup services offer great scalability. Users can adjust their storage needs on the fly, responding to data growth without physically adding hardware or infrastructure. This dynamic scalability ensures that businesses of any size can tailor their backup solutions to fit their exact requirements, all while minimizing initial outlays for hardware. The second point is accessibility. With cloud-based backups, data is retrievable from any location with internet access, making it ideal for businesses with remote teams or those requiring constant access to their data for operational continuity. This level of accessibility promotes flexibility in work arrangements and ensures that data recovery efforts can be initiated from anywhere, significantly reducing downtime in the event of data loss. Third is cost efficiency. Cloud backup offers a cost-effective alternative to traditional, capital-intensive storage solutions because it is subscription-based. Businesses can lease the exact amount of storage they need, sidestepping the hefty upfront costs associated with purchasing and maintaining physical backup infrastructure. And lastly, cloud-based storage is especially effective for disaster recovery. With data backed up across multiple geographically separate data centers, cloud backups are a reliable option for disaster recovery strategies. This geographic dispersion ensures that even if one data center is compromised due to natural disasters or other catastrophic events, other locations can serve as reliable fallbacks, enabling swift data recovery and business continuity. Next, let's talk about some disadvantages of cloud backup. First, the efficacy of cloud backup depends on internet service availability and quality. Data backup and retrieval times can vary widely based on internet speed and bandwidth, potentially hampering urgent data recovery efforts or slowing down regular backup processes. This reliance on internet connectivity places a premium on having stable, high-speed connections for businesses relying on cloud backups. Then there is the concern about security. Despite the rigorous security protocols employed by cloud service providers, the external nature of cloud storage introduces potential vulnerabilities. Concerns over data privacy, unauthorized access, and breaches persist. This makes it crucial for businesses to understand and mitigate these risks through encryption, secure password practices, and vetting of cloud providers' security credentials. Cloud backup also goes along with ongoing costs. While initially more cost-effective, the subscription model of cloud backups means that costs will increase over time. For long-term storage needs, these costs can eventually surpass those associated with setting up and maintaining local backup solutions. Businesses must carefully consider their long-term data storage strategies and the associated costs to determine the most economical approach. Let's move on to the advantages and disadvantages of local backup. First, local backup has the advantage of control. Local backups offer complete control over the data and backup processes, with data stored on premises and managed directly by the organization or individual. Next is the speed it offers. Data restoration from local backups can be faster than cloud backups as it does not rely on internet speed, making it ideal for large volumes of data. And lastly, there is the aspect of security. Local backups provide more security for businesses concerned about data sovereignty and privacy by keeping data physically accessible and under direct control. However, the cost and maintenance of local backup are things to consider. Initial setup costs for local backup solutions can be high, including expenses for hardware, software, and ongoing maintenance. It also has scalability limitations. Expanding storage capacity can require additional hardware purchases, making scalability more challenging and expensive than cloud solutions. And finally, local backup is vulnerable to local disasters like fires and floods. Local backups can be susceptible to the same local disasters that might compromise their primary data. This makes them less effective for disaster recovery. Now that you know the pros and cons of both options, it's important to know that there is an alternative solution combining the best of both: hybrid backup solutions. Recognizing the strengths and weaknesses of both cloud and local backups, many organizations opt for hybrid backup solutions. These approaches combine cloud and local aspects, leveraging the cloud for disaster recovery and long-term archiving, while maintaining a local backup for quick data access and recovery. Hybrid solutions offer a balanced approach, providing the security and speed of local backups with the scalability and accessibility of cloud backups. In conclusion, choosing between cloud and local data backup strategies depends on various factors, including the data size, budget constraints, access needs, and security considerations. Cloud backups shine in scalability, cost efficiency, and disaster recovery. Meanwhile, local backups offer greater control, speed, and security. Hybrid models, however, provide a comprehensive solution that mitigates the limitations of each method, offering businesses and individuals a flexible and effective data backup strategy. System recovery is a crucial pillar in data management. It ensures business continuity and data integrity in the face of unforeseen events like system crashes, malware attacks, or hardware failures. This video unpacks system recovery within the broader framework of data backup strategies. Over the next few minutes, you will learn about the different system recovery techniques and the steps of the system recovery process. Let's start by pinpointing what system recovery is and why it's important. System recovery involves the processes and methodologies to restore computer systems, applications, and data to a fully operational state after a compromise or failure. This can range from restoring minor data corruption to tackling significant disasters that leave systems non-functional. The significance of system recovery goes beyond simply restoring data. It is about ensuring the continuity of business operations, minimizing downtime, and preserving the integrity and availability of critical information. Data is frequently considered the cornerstone of organizations. System recovery is crucial as it safeguards against data loss, which can significantly impact business operations, financial stability, and reputation. Effective system recovery strategies ensure that organizations can quickly rebound from IT disasters, thereby mitigating the impact on customer service, business operations, and compliance with regulatory requirements. Let's explore some techniques for system recovery, each suited to different scenarios and requirements. First is system restore points. This method involves creating snapshots of system files, program files, and registry settings at specific points in time. In the event of a system issue, users can revert the system to a previous state, effectively undoing recent changes that may have caused the problem. Next is recovery partitions. Many modern computer systems come with a dedicated partition on the hard drive that contains the original operating system, drivers, and factory settings. Accessing the recovery partition during startup allows users to reset the system to its factory state. Another technique constitutes full system backups. This comprehensive approach involves creating a complete image of the entire system at a specific point in time. In case of a system failure, the full image can be restored, bringing the system back to its state at the time of the backup, including the operating system, installed applications, settings, and data. Lastly, VM snapshots is a technique that captures the state of a virtual machine at a specific moment. They allow for the quick and efficient rollback of the VM to a previous state without needing a full restoration. This is particularly useful in virtualized environments for testing updates or changes without affecting the primary system configuration. Next, let's unpack the key steps of the system recovery process. First is assessment and planning. This step involves assessing the extent of the system failure or data loss. This will help to identify the most suitable recovery method based on the nature of the incident and the available backups. Step 2 is the selection of a recovery source. Depending on the backup strategy in place, this may involve choosing between different restore points, recovery partitions, or full system backups. Step 3 is the execution of the recovery process. This step involves the actual restoration of the system using the chosen method. For system restore points and recovery partitions, this may be initiated through the system's boot menu. For full system backups, specialized software may be required to apply the system image. Fourth is verification and testing. After the recovery process is complete, it's essential to verify that the system is fully functional and that all critical data and applications are intact. This may involve running diagnostic tools and performing manual checks to ensure system integrity. Finally, step 5 is the post-recovery analysis. Conducting a post-recovery analysis can provide valuable insights into the cause of the failure and help refine the backup and recovery strategy to prevent future incidents. In conclusion, system recovery is a fundamental aspect of a robust data backup strategy, serving as the last line of defense against data loss and system failures. By understanding the various recovery techniques available and following a structured recovery process, organizations can ensure the resilience of their IT infrastructure, safeguard critical data, and maintain uninterrupted business operations. This video provided you with essential knowledge. As technology evolves and the volume and value of digital data continue to grow, the role of system recovery in disaster recovery planning and business continuity management will only become more critical. Well done on reaching the end of this module on robust data backup and recovery. You've covered a lot of ground on data backup strategies, data processing, and data storage and compression. At this point, you should be able to describe data compression types and use cases, discuss the processing and storage of common types of data, video, audio, and document, and discuss data backup methods and strategies in implementing effective data recovery strategies, ensuring data integrity and availability. This video will step you through what you've learned to help you identify what areas you might want to revisit before attempting the module quiz. In Lesson 1, you were introduced to fundamental concepts in data storage and compression. You started by learning about data storage technologies, from traditional hard drives and solid-state drives to newer forms of storage like cloud and network-attached storage or NAS solutions. You then specifically focused on NAS and how it provides centralized, scalable data storage accessible over a network. You expanded your knowledge of the characteristics of different storage media types. Magnetic disks, or HDDs, provide cost-effective, large-capacity options suitable for archival storage and everyday computing. In contrast, solid-state drives, or SSDs, and flash memory enhance performance, reliability, and portability, catering to demands for high-speed computing and flexible storage. You also learned about the impact of storage interfaces like Serial ATA or SATA, Peripheral Component Interconnect Express or PCIe, and Non-Volatile Memory Express or NVMe. Next was disk partitioning and file systems and their importance in data organization and access. You learned about the master boot record, also known as MBR, or the GUID partition table, or GPT for short. The MBR is an older standard that supports disks up to 2 TB in size and allows up to 4 primary partitions. In contrast, GPT is a newer standard that supports disks larger than 2 TB and allows for virtually unlimited primary partitions. Recall that a file system keeps track of all the files on a disk, including their physical location on the drive, their size, and their attributes like permissions and timestamps. Common file systems include NTFS, or New Technology File System, FAT32, or File Allocation Table 32, and exFAT, or Extended File Allocation Table. What really stood out in this lesson was the video about compression techniques and their applications in optimizing storage efficiency. Recall that lossless data compression allows for the original data to be perfectly reconstructed from the compressed data. While lossy techniques allow for some loss of information, trading data fidelity for a higher compression ratio. You also gained practical advice for troubleshooting storage media failures, data corruption, and issues with compressed files. In Lesson 2, you learned all about data processing and its importance in modern computing. By transforming raw data into actionable insights, organizations can drive better decision-making, enhance operational efficiency, and secure a competitive advantage in the marketplace. Can you recall the steps of the industry-renowned ETL process? Extract, transform, and load. Organizations use the ETL process to efficiently handle data from multiple sources, ensuring that it is accurate, consistent, and readily available for analysis and decision-making. You then zoomed in on image and video processing. You learned about the unique characteristics of image formats such as JPEG, PNG, GIF, and WebP, and covered essential video processing terms like bitrate and resolution. Remember the various video formats: MP4, AVI, and MOV. And don't forget about the role of GPUs in image and video processing. Next, you learned about video codecs such as H.264 or AVC. These technologies are crucial for the efficient encoding and decoding of digital video content. You covered the basics of compression and decompression and how codecs reduce file sizes while striving to maintain quality. Moving on to audio processing, you now know about fundamental concepts such as audio compression, noise reduction, and digital representation of sound and their profound impact on multimedia. You discovered that voice recognition technologies and broadcasting greatly benefit from audio processing advancements and that AI and machine learning open new possibilities in sound manipulation. Next, you learned about the portable document format or PDF and how it ensures seamless and secure information exchange. You focused on PDF features such as formatting preservation, password protection, and digital signatures, as well as its functionalities in line with accessible document design. One of the most valuable readings in this lesson addressed common issues with digital files and media and how to resolve them systematically. You covered how to diagnose file corruption, solve incompatibility issues, and address playback issues. In the last lesson on data backup strategies, you were introduced to fundamental concepts related to backup, such as the 3-2-1 backup rule, the frequency of backups, and the distinction between backup and storage. Recall that several factors should be considered when choosing a backup solution, including the sensitivity and volume of the data, the desired frequency of backups, and the budget. You also learned about RAID or redundant array of independent disks as a crucial technology for data redundancy and backup. The various RAID levels, such as RAID 0, 1, 5, and 10, offer different balances of data redundancy, performance, and storage capacity. However, RAID is not a substitute for a backup strategy. So, implementing RAID should be part of a broader data protection plan. You gained comprehensive knowledge about creating such plans, including an overview of traditional backup methods like full, incremental, and differential backups, and more advanced strategies such as mirroring and replication. You also explored various media used for backups, including magnetic tapes, external hard drives, and network-attached storage. Next, you learned about the differences between cloud and local data backup. Cloud shines in scalability, cost efficiency, and disaster recovery, while local offers control, speed, and security. Hybrid solutions balance local security and speed with cloud scalability and accessibility. Remember, another crucial part of a robust data backup strategy is system recovery methods, such as system restore points, recovery partitions, full system backups, and VM snapshots. By reviewing practical examples and best practices for data recovery strategies, you should now be better equipped to recover critical data, maintain continuity, and secure operations against unforeseen digital threats. You learned so much, isn't that great? Don't hesitate to revisit the parts that you feel uncertain about, and good luck with the module quiz. Congratulations! If you're watching this video, it means you have progressed through the content section of the course on essential aspects of software, hardware, and data backup. In the final section, you will have the opportunity to apply what you've learned by engaging in a practical project. The aim of this course was to equip you with the skills necessary to ensure security and integrity in digital environments. It covered everything from software and hardware configurations to robust data backup and recovery strategies. You should now be able to implement secure software configurations, implement secure hardware configurations, and develop robust data backup and recovery strategies. Let's recap what you've covered to ensure you're fully prepared to implement these skills in the upcoming course project and final assessment. In the first module, you learned about secure software configurations, access control, privilege management, and installation best practices. You started with an introduction to core software security concepts such as defense in depth and common security threats such as hacking, phishing, and malicious software. You then covered the importance of end-user license agreements or EULAs. Recall the potential legal and security consequences of ignoring the terms set out in a EULA, including privacy violations, software misuse, and unexpected charges or penalties. Next, you zoomed in on malware, focusing specifically on viruses, trojans, and worms. You learned how these malicious programs infect and damage systems, including their methods of spreading, the kind of damage they cause, and the implications for software security. Most importantly, you discovered how antivirus and anti-malware solutions safeguard your systems. In the lesson about access control and privilege management, you covered user authentication issues and the implementation of single sign-on or SSO systems. Different access control models such as DAC, MAC, and RBAC were explained, along with the risks involved with mobile application permissions. Next, you discovered the critical role of software updates in maintaining system security. Can you recall the common pitfalls in software installation and updates? They include neglecting system compatibility checks, ignoring user agreement details, bypassing custom installation options, and installing random software. Then you learned about the risks posed by third-party software and supply chain attacks and best practices for mitigating these risks, including verifying software sources, monitoring for unusual software behavior, and keeping abreast of software security updates and patches. Module 2 focused on secure hardware configuration. Here you gained insights into basic input-output system or BIOS, hardware security, and physical access to devices. You learned about the evolution of BIOS and Unified Extensible Firmware Interface or UEFI, highlighting the advancements in firmware technology. For instance, UEFI introduced enhanced features, security benefits, secure booting, and performance improvements. After this, you explored the role of hardware firewalls and their key functionalities, including packet filtering, stateful inspection, and creating demilitarized zones or DMZs. Next up was original equipment manufacturers or OEMs and how they contribute to the security of hardware devices. For instance, OEMs play a vital role in designing, producing, and securing hardware components and implementing firmware security measures. You then zoomed in on the Trusted Platform Modules or TPM and how it integrates with Windows operating systems, enhancing security measures for data protection, encryption, and authentication processes. Hereafter, you explored the critical aspect of storage encryption in safeguarding data and the different types, including full disk encryption, and file-level encryption. What's more, you explore the threats associated with USB devices and strategies to mitigate these threats, such as encryption, access control implementation, and regularly scanning USB devices for malware. The next lesson focused on strategies for securing physical devices, from bring your own device or BYOD policies to radio frequency identification or RFID technology. In the third module, you addressed the critical areas of storage and compression, data processing, and data backup strategies. You covered network-attached storage or NAS systems, storage media types, disk partitioning, and data compression. What stood out in this lesson was the video about lossless and lossy data compression techniques and their applications in optimizing storage efficiency. You also gained practical advice for troubleshooting storage media failures, data corruption, and issues with compressed files. The lesson on data processing was critical. Here you learned about processing different data types like video and audio, the use of various codecs, and PDF handling. Think back about PDF's many attributes, like preserving a document's original formatting and being platform independent. And can you recall what you've learned about video compression and decompression and how codecs reduce file size while striving to maintain quality? In the final lesson, you covered data backup and recovery strategies, ensuring data integrity and availability. You were first introduced to RAID, or redundant array of independent disks, and how the different RAID levels differ in data redundancy, performance, and storage capacity. Can you recall the different data backup methods, like full, incremental, and differential backups, and strategies such as mirroring and replication? And don't forget the advantages and disadvantages of cloud and local data backup options, and that hybrid backup models are the best of both worlds. Finally, you learned about the steps involved with system recovery and different methods, including system restore points, recovery partitions, and full system backups. That brings us to the end of this recap video. The last part of the course will guide you in completing a final course project where you will develop a data strategy for a specified scenario. It will cover key aspects of data management, such as data acquisition, storage, analysis, and security. The goal is to implement a practical and effective data solution that meets the business's needs. This course has provided a thorough grounding in the essential aspects of software, hardware, and data backup through engaging learning material and practical activities. You are well prepared to implement these skills in the final course project and graded assessment. Remember, don't hesitate to revisit any topic you're unsure about. Good luck! Congratulations on reaching the end of this course on essential aspects of software, hardware, and data backup. By completing this course, you've developed the essential skills to safeguard digital environments and manage data backups effectively, addressing vital needs in today's tech-driven landscape. You've proven that you are well prepared to fulfill IT support-related responsibilities such as implementing secure software configurations, implementing secure hardware configurations, and developing robust data backup and recovery strategies. Most importantly, you completed the final course project by developing a data strategy that addresses the specific business needs of a fictional company. Well done on taking the first steps toward your future career. In successfully completing all the courses in this program, you will earn a Coursera certification. This program will enhance your IT support skills and deepen your understanding of IT support issues. This globally recognized certification significantly boosts your credibility and appeal to prospective employers. Moreover, it showcases your dedication to ongoing learning and career growth in areas including cloud computing and various productivity tools. The certification can benefit you whether you are seeking an entry-level position in IT or looking to demonstrate proficiency with Microsoft 365 technologies. Completing the program also serves as an essential stepping stone in your preparation for the Microsoft MS900 exam. Passing this exam will earn you the Microsoft 365 Fundamentals certification. This certification demonstrates foundational knowledge of Microsoft 365 services, including cloud concepts, security, compliance, and collaboration tools. The Microsoft 365 Fundamentals certification validates your understanding of essential concepts in cloud-based productivity and collaboration solutions. To complete the exam, you should be able to recommend Microsoft 365 solutions that address common organizational IT challenges. You should also gain an understanding of how Microsoft 365 solutions improve productivity, facilitate collaboration, optimize communications, help secure data and identity, and facilitate compliance. In summary, this course has enhanced your knowledge and skills in key aspects of IT security and data management. But what comes next? There's more to learn, so it's a good time to register for the next course. In the next course, you will explore key elements of cybersecurity and privacy. You will learn about password management strategies, privacy settings on operating systems and applications, and login keychains on various platforms. This course will equip you to implement cybersecurity concepts to ensure user data privacy. You've really excelled so far, and you should feel proud of your progress. The skills you have acquired demonstrate your motivation, competence, and willingness to embrace new challenges to prospective employers. Wishing you all the best as you continue on your educational path.